Hello students, hello ಎಲ್ಲರಿಗೂ hi and welcome you all to the Vedantu Karnataka. ನಾನು ನಿಮ್ಮ ಮಾಸ್ಟರ್ ಟೀಚರ್ Rithika Ma'am. So ಇವತ್ತಿನ ಸೆಷನ್ ಯಾವ್ದಪ್ಪ ಫುಲ್ ಆನ್ FA. ಸೊ FA ಎಕ್ಸಾಮ್ಸ್ ಬರ್ತಿದೆ, ಅದ್ರ ಸಲುವಾಗಿ ನಿಮಗೆ ನಿಮ್ಮ ಪೋರ್ಷನ್ ಪ್ರಕಾರ ಎಲ್ಲ ತರದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ತಗೊಂಡಿದ್ದಾರೆ. 1 marks ಕ್ವಶನ್, 2 marks, 3 marks, 5 marks ಎಲ್ಲ ಮಾಡೋಣ ಇವತ್ತು, ಆಯ್ತಾ? ಸೊ everyone are excited? Yes, let me check it out once. Am I audible and visible properly to everyone? I'll just check once. Excited? Yes, it's good. Yes, we will do the numerical problems also. ಯಾವ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಇದೆಲ್ಲ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಇದೆ ರೈಟ್? ಸೊ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ದು ಎಲ್ಲ numerical problems ನಾನು ಮಾಡೋಣ, ಆಯ್ತಾ? Yes. Okay, then I'm audible and visible properly. Then let's start it. Just give me 1 second. Yes. Okay then. ಎಸ್, ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಅಂದ್ರೆ ಏನಂದ್ರೆ ಯಾವ್ಯಾವ ನಿಮಗೆ ಪೋರ್ಷನ್ ಇದೆ ಅಲ್ಲ, ನಾನು ಆಲ್ರೆಡಿ ಒಂದು ನಿಮಗೆ ವಿಡಿಯೋ ಮಾಡಿದ್ದೆ. ಆ ವಿಡಿಯೋನಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೆ ನಿಮಗೆ ಏನಂದ್ರೆ ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸ್ ಯಾವ್ಯಾವ ಪೋರ್ಷನ್ ಇದೆ ನಿಮ್ಮ ಕಾಲೇಜ್ನಲ್ಲಿ. ನಾನು ನಿಮಗೆ ತೋರಿಸಿದ್ದೆ. I had shown you people one screenshot also about the portion. ಆ ಪೋರ್ಷನ್ ಪ್ರಕಾರ ನಿಮ್ದು ಇದೇನೋ ಇಲ್ಲ ಅನ್ನೋದನ್ನು ಕೇಳಿದ್ದೆ. few people have responded, few people have not responded. ಇವತ್ತು ನೀವು ನನಗೆ ಸಜೆಷನ್ ಕೊಡ್ಬೋದು, ಯಾವ ಚಾಪ್ಟರ್ಸ್ ಇಲ್ಲ ಮ್ಯಾಮ್, ಯಾವ ಚಾಪ್ಟರ್ಸ್ ಇದೆ ಅನ್ನೋದು ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿ. ಐ ವಿಲ್ ಆಲ್ಸೋ ಗೆಟ್ ಟು ನೋ ದಟ್ ಯಾವ ಚಾಪ್ಟರ್ಸ್ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ನಿಮ್ ಕಾಲೇಜ್ನಲ್ಲಿ ಯಾವ ಚಾಪ್ಟರ್ಸ್ ನಿಮ್ಗೆ FA ಕೊಟ್ಟಿದ್ದಾರೆ ಅನ್ನೋದು ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ಮೋಸ್ಟ್ ಆಫ್ ದ ಕಾಲೇಜಸ್ ಇಟ್ಸ್ ಲೈಕ್ FA-2. Okay, so most of the colleges it's like FA-2. Some students, some colleges nalli FA-3 anta ide, some colleges it's like FA-2 itself. Okay, andre FA-1 amele midterm exams amele FA-2 anta ide. So it depends on yav college nalli hege gine anadu, right? Yes, portions Vaishnavi ma'am calls. Yes, I got the portion. I'm just asking you people, yaar bere hudugore yaar idaralla avrigunu just heli ade portion correct ideno illa annodu, aita? Done. Let's start then. Amines, biomolecules, coordinate compounds. Biomolecules is also there. Biomolecules has been not included actually because biomolecules was there, not there in the portion. Okay then. Let's start the class. Yes, chemical kinetics is there, carboxylic acid is there, everything is there. Ravi, Vijay. Okay then, start ಮಾಡೋಣ. First chapter I'm going to take is about the chemical kinetics itself. So chemical kinetics ಇಂದ ಯಾವುದು short questions ಬರುತ್ತಲ್ಲ ಅವನ್ನಷ್ಟೇ ತಗೊಂಡಿರೋದು ನಾನು, ಆಯ್ತಾ? So ಈ coming 2 hours which are there, you need to be very active in the chat box. So ನೀವು ನನಗೆ ಸಪೋರ್ಟ್ ಮಾಡ್ಕೊಂತಿದ್ರೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ನಿಮಗೂ ತಿಳಿಯುತ್ತೆ, ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ, ರೈಟ್? ಮ್ಯಾಮ್ ಐ ವಾಂಟ್ 50+ ಯಾಕಪ್ಪ, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿನೇ ಬೀಳುತ್ತೆ. ನೀನು ಇದಷ್ಟೇ ಓದು ಸಾಕು. ಈ PDF ಅನ್ನ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ಹಾಕಿರ್ತೇವೆ. ಇದಷ್ಟೇ ಓದಿದ್ರೂ ಆರಾಮಾಗಿ ಔಟ್ ಆಫ್ ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ಬಿಕಾಸ್ ದೀಸ್ ಕ್ವಶನ್ಸ್ ಆರ್ ಮೋಸ್ಟ್ ರಿಪೀಟೆಡ್ ಅಂಡ್ ಶಾರ್ಟ್ ಆಗಿ ಕ್ವಶನ್ಸ್ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ, ಆಯ್ತಾ? ಶಾರ್ಟ್ ಆಗಿ ಕ್ವಶನ್ಸ್ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ದೆನ್ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್. ನಿಮಗೆ ಗೊತ್ತು ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಇಸ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಫಾರ್ ಯುವರ್ KCET ಆಲ್ಸೋ and for your coming main boards exams also. Clear? So let's start. How to get our notes, ma'am? It will be in the description, or else you can directly log in through the Vedantu app and you will receive it. Okay? Let's start then. Define the rate of chemical reaction and write its unit. So ಏನಪ್ಪ rate of chemical reaction? Chemical reaction rate ಏನು and write its unit they have told. Okay, so come on, ಎಷ್ಟು ಮಂದಿಗೆ ಯೂನಿಟ್ಸ್ ಗೊತ್ತಿದೆ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿ, ಆಯ್ತಾ? ಸೊ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ದ ಚೇಂಜ್ ಇನ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಎನಿ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಆರ್ ದ ಪ್ರಾಡಕ್ಟ್. ಸೊ ಎನಿ ಚೇಂಜ್, ಸೊ ಏನ್ ಚೇಂಜ್ ಇರುತ್ತೆ ಅದರಲ್ಲಿ? ಒನ್ ಸೆಕೆಂಡ್. So any change in the concentration of any reactant or a product per unit time nalli, okay, per unit time nalli the rate of reaction which is changing in concentration of the reactant and the product. That is going to be what? Chemical reaction. Clear? So ಈಗ reactant ಇರುತ್ತೆ, product ಇರುತ್ತೆ, ಯಾವ concentration ಮೇಲೆ product ಅನ್ನ find ಮಾಡ್ತೇವಲ್ಲ ಅದಕ್ಕೆ chemical reactions ಅಂತ ಕರೀತಾರೆ. ಮತ್ತೆ ಅದ್ ಯಾವ rate ಇಂದ find ಮಾಡ್ತೇವಲ್ಲ ಅದಕ್ಕೆ rate of chemical reaction ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರಾ? Amines, biomolecules, electrochemistry, coordination, compounds. Okay, so 4 chapters are there, Ravichandran. Okay, no problem. Next time ಈಗ ಯಾವ ಚಾಪ್ಟರ್ಸ್ ತಗೊಂಡಿದ್ದಾರಲ್ಲ ಅವ್ನು ಸ್ಟಡಿ ಮಾಡಿ, ಯಾವ ಚಾಪ್ಟರ್ಸ್ ಇಲ್ಲಲ್ಲ ಅವ್ರನ್ನ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ತಗೋತೇನೆ, ಆಯ್ತಾ? ನಾಟ್ ಅನ್ ಇಶ್ಯೂಸ್. ಯಾವ ಸೆಷನ್ಸ್ ಯಾವ ಕ್ವಶನ್ಸ್ ಇಲ್ಲಲ್ಲ ಅವ್ರು ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ತಗೋತೀನಿ, ಏನೂ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಆಯ್ತಾ? So let's start then. Rate of the reaction is going to be what? Rate of the reaction is also can be written as decrease in concentration of the reactant R divided by time interval. Okay, divided by time interval. I'm giving you people all the solutions also because ಇದು ಬಂದು PDF ನೋಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಿಮಗೆ ಸಾಕು, ಆರಾಮಾಗಿ ಪಾಸ್ ಆಗ್ಬೋದು. ಇದೇನಿಲ್ಲ, ನಾನು ಬರೀ ಕ್ವಶನ್ ಕೊಡ್ತಿದ್ದೇನೆ, ಆಮೇಲೆ ಆ ಕ್ವಶನ್ ಆನ್ಸರ್ ನೀವು ಎಲ್ಲಾ ಕಡೆ ಹೋಗಿ ಹುಡುಕ್ಯಾಡಬೇಕು, ಆಮೇಲೆ ಅಂತ ತಗೊಂಬಂದು ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಂತ ಏನೂ ಇಲ್ಲ. ಸೊಲ್ಯೂಷನ್ ಆಲ್ರೆಡಿ ಇಟ್ಸ್ ದೇರ್ ರೆಡಿಮೇಡ್. ಐ ಆಮ್ ಗಿವಿಂಗ್ ಯು ಎವ್ರಿಥಿಂಗ್, ಜಸ್ಟ್ ಯು ನೀಡ್ ಟು ಸಿಟ್ ಅಂಡ್ ರೀಡ್ ಇಟ್ ಅಂಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವೈಲ್ ಐ ಆಮ್ ಟೀಚಿಂಗ್ ಇಟ್. ಓಕೆ, ಸೊ ಎಷ್ಟೇ ಆದ್ರೂ ಸಾಕು ನಿಮಗೂ, ಆಯ್ತಾ? ಸೊ our rate of the reaction is going to be what? Decrease in the concentration of the reactant R divided by time interval. Clear? So it is also equal to increase in the concentration of the product P and the time interval. Clear? Examples what we can take: 2N2O5, which is going to give us 4NO2 plus O2. 4NO2 plus O2. Clear? So it also can be written as this equation. According to this equation, how you are going to rate, how you are going to mention this equation in the form of a rate form, we should understand. Okay, rate is equal to minus half delta N2O5 divided by delta T is equal to plus 1 by 4 delta NO2 divided by delta T. That also can be written as delta O2 divided by delta T. Means what? According to this equation, you have written it in the form of a rate. Clear? So rate form nalli bardidera. Next, for the solution, rate is also equal to the concentration. Okay, our unit anta ಕೇಳಿದಾರೆ ನಮಗೆ, right? Unit is also important. ಇದು ಬಹಳ ಸಲ ರಿಪೀಟ್ ಆಗಿರೋ ಕ್ವಶನ್. Okay, this is also important. They will ask for 1 marks also. Okay, exam nalli FA nalli 1 marks gunu kelbodu idanna. So concentrate properly. Okay, rate is also equal to concentration divided by time taken. That is concentration ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬಹುದು? mole per liter ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬಹುದು. mole per liter divided by second. Clear? So that is going to be what? mole per liter per second. For gaseous reaction, it is going to be the ATM. It is going to consider on the phases of atmosphere. Okay, 1 second guys. Yes, clear? Next, explain any 2 factors which are affecting the rate of the reaction. So ಯಾವ 2 factors ಇದೆ, ಆ rate of the reaction ಗೆ ಹೇಗಪ್ಪ ಎಫೆಕ್ಟ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ನೋಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ನೇಚರ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್. ನೇಚರ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಅಂದ್ರೆ ಯಾವ ತರ ನೇಚರ್ ಇದೆ ಅದರದ್ದು, ವೆದರ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಹೈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಆರ್ ವಾಟ್, ವೆದರ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಹೈ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆರ್ ವಾಟ್, ಅದನ್ನ ನೀವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಫಸ್ಟ್, ಆಯ್ತಾ? ಸೊ ನೇಚರ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್, ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ಸಾಲಿಡ್, ಲಿಕ್ವಿಡ್, ಗ್ಯಾಸಿಯಸ್, ಅದು ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ಸ್. Clear? Next, it is going to be the concentration of the reactants. Like higher the molar concentration, akasmat molar concentration ಜಾಸ್ತಿ ಇದ್ರೆ reactant will start reacting faster. Reactant will start reacting faster, and the rate of the reaction and the vice versa. If in case the concentration, molar concentration of the reactant is lesser idre, rate of the reaction ಏನಾಗುತ್ತಪ್ಪ? rate of the reaction ಕಡಿಮೆ ಆಗುತ್ತಾ ಹೋಗುತ್ತೆ. That is called as vice versa. Clear? Next comes the temperature. For every 10 degrees Celsius rise of the temperature, reaction rate doubles or more. It is going to double or it's going to be the more. Clear? The temperature, that for every 10 degrees Celsius, that the temperature, reaction and the rate of the doubles or the more. Clear? Next comes the presence of the catalyst. Presence of the catalyst. So you need to be very active in the chat box when I am explaining it. Then only I am going to give you people the PDF. So class PDF ಬೇಕಂದ್ರೆ ಕ್ಲಾಸ್ ನು ಚೆನ್ನಾಗಿ ಕೇಳಬೇಕು. ನಾನು ನೋಡ್ತೀನಿ ಎಷ್ಟು ಮಂದಿ ಕೇಳ್ತಿದ್ದಾರೆ, ಕ್ಲಾಸ್ ಅನ್ನ ಹೇಗೆ ಕೇಳ್ತಿದ್ದಾರೆ, ಎಷ್ಟು ರೆಸ್ಪಾಂಡ್ ಮಾಡ್ತಿದ್ದಾರೆ, ಅದರ ಪ್ರಕಾರ ನಾನು PDF ಅನ್ನ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ಹಾಕೊಳ್ಳು, ಇಲ್ಲಾಂದ್ರೆ ಆ PDF ಹಾಕಲ್ಲ. ಸೊ ಸ್ಟೇ in the class and sit and listen to the class first. Okay, direct PDF ಕೊಡಲ್ಲ ನಾವು. Okay, Presence of the catalyst ಏನು, presence of the suitable catalyst increases the speed of the chemical reaction. It will start increasing the speed of the chemical reaction. Because of that, without itself being the consumed in the reaction, catalyst helps to attain the equilibrium quickly without disturbing the state of the equilibrium. Presence of the catalyst ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೀನಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ಫಸ್ಟ್. ಸೊ ಈಗ catalyst ಇದೆ, ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಷನ್ ರಿಯಾಕ್ಟೆಂಟ್ ಇಂದ ಪ್ರಾಡಕ್ಟ್ ಗೆ ಫಾರ್ಮ್ ಮಾಡುತ್ತ ಮುಂದೆ catalyst ಬಹಳ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. So what is the work of the catalyst is the reaction will be faster. It will make the reaction faster. ಈಗ ನನಗೆ ಒಂದು ನಿಮಿಷದಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಬೇಕಿದೆಯಪ್ಪ, ಓಕೆ, catalyst will make that happen. If in case catalyst is not there, the reaction is taking time till 10 minutes. Okay, ಆ ರಿಯಾಕ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ಲಿಕ್ಕೆ 10 ನಿಮಿಷ ತಗೋತಿದೆ. ಅಕಸ್ಮಾತ್ ನಾ catalyst ಯೂಸ್ ಮಾಡಿದ್ರೆ it will become faster. Right? So presence of catalyst is also going to affect a lot on the factors affecting the rate of the reaction. Clear? Next comes the temperature also. Understood with the temperature, ನೀವು ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಅಪ್ಲೈ ಮಾಡ್ತಾರಲ್ಲ ಅಷ್ಟು ಫಾಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? ನೆಕ್ಸ್ಟ್, ಈಗ ನೀವು ಏನಾದರೂ ಕುಕ್ ಮಾಡ್ತಿದ್ರೂ ಸೇಮ್ ಅದೇ ಆಗುತ್ತಲ್ಲ. ವೆನ್ ಯು ಕುಕಿಂಗ್ ಇಟ್ ಆಲ್ಸೋ ಜಾಸ್ತಿ ಬೇಕಾದ್ರೆ ಗ್ಯಾಸ್ ಜಾಸ್ತಿ ಮಾಡ್ತಾರಾ, ಕಡಿಮೆ ಬೇಕಂದ್ರೆ ಕಡಿಮೆ ಮಾಡ್ಕೋತಾರಾ. ರೈಟ್? ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. State rate law expression and write its mathematical form. So rate law expression anna find ಮಾಡಬೇಕು, plus you need to write its mathematical form also. Clear? What is a rate law? So rate of the reaction is directly proportional to the product of the molar concentration. So what is the rate of the reaction? Its rate of reaction is directly proportional to the product of the molar concentration of the reactants with each concentration. Be active in the chat box. Understanding everyone? With each concentration terms which will be raised some with the powers which may or may not be the same. That is about the stoichiometric coefficient, and it has been balanced chemical equation. It is going to be balanced chemical equation. So that is simple equation ಕೊಡ್ತಿನೋದಕ್ಕೆ AA plus BB. Okay, AA plus BB, it is going to get a product. Clear? Now rate law is going to be considered as rate is directly proportional to A and B. Then alpha A alpha and beta B. Then so rate is also called as this proportionality constant is going to be the K. Okay, this proportionality constant is going to be the K, that is A alpha beta B. Clear? Understood? This is going to be the state law expression of a write its mathematical form annanu barದ್ಬಿಟ್ವಿ. Done? Mathematical form ಆಯ್ತು. That will be the mathematical form, and this will be the rate law equation. ಏನಾಗುತ್ತದು? Rate law equation ಆಗುತ್ತೆ. Clear? Done? Understanding? Yes, no, you should tell that, no? Yes, no, you should tell these things also, then only I'm going to get it. Okay, next comes, what are the units of the rate constant for the 0, first, second and the third order reaction? Okay, ಏನೇನ್ ಯೂನಿಟ್ ಇದೆ, ಫಸ್ಟ್ ಆರ್ಡರ್ದು, ಸೆಕೆಂಡ್ ಆರ್ಡರ್, ಥರ್ಡ್ ಆರ್ಡರ್ದು, ಮತ್ತೆ 0th ಆರ್ಡರ್ದು ಏನಪ್ಪ ಯೂನಿಟ್ಸ್ ಇದೆ ಅನ್ನೋದು. ಓಕೆ, now 0 order is going to be what? Mole per liter. Just now we have found out the for the rate how much will be, what will be the unit, right? ಇಲ್ಲಿ ಮಾಡಿದ್ವಲ್ಲ just now, ತೋರಿಸ್ತಾನೆ ಇಲ್ಲಿ ಈಗ ಸದ. Okay, ಇದರಲ್ಲಿ ಆಲ್ರೆಡಿ ಮಾಡಿದ್ವಿ, ರೈಟ್? ರೇಟ್ ಇದ್ದು ಆಲ್ರೆಡಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್, ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ತೇವೆ, ಮೋಲ್ ಪರ್ ಲೀಟರ್, ಆಮೇಲೆ ಟೈಮ್ ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡ್ತೇವೆ, ಸೆಕೆಂಡ್ ಇಂದ, ರೈಟ್? ಸೊ ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಏನ್ ಬರುತ್ತೆ, ಮೋಲ್ ಪರ್ ಲೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ವಿ ಗಾಟ್ ಟು ನೋ ಅಬೌಟ್ ದ ರೇಟ್ ನೌ. What will be according to the zero law and according to the, one second, where did it go? Yes, 0ದು ಮತ್ತೆ ಫಸ್ಟ್ ಮತ್ತೆ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಆರ್ಡರ್ದು ಹೇಗಾಗುತ್ತೆ ಅನ್ನೋದು ನೋಡ್ಕೋಬೇಕು, ಆಯ್ತಾ? ಸೊ ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ ಇಸ್ ಅ 0 order, that is going to be what? Mole per liter, that is will be per second, and per liter, that is mole per liter per second, or it is also given as pressure, that is ATM per second. Clear? Next comes what? N is equal to 1. Okay. If in case it is a n is equal to 1, if in case it is going to be n is equal to 2 or n is equal to 3. So how it will be? So illi same irutte, ella same irutte. Just the thing is raised to 0 ade when it is 0th order. Okay. Yavaga 0 ade when it is 0th order. So when it is going to be the 1 first order, avag 1 hakteve. Clear? So ee tara barilla illi. Okay. 1 hakteve. If it is the second order, we are going to put second. Clear? If it is a third order, we are going to put it as third. Clear? So 0th order, first order, second order and third order. Clear? This is how the units will be measured. Then next question. Define order of reaction. Give an example for the 0, first, second and fractional order of the reaction and the fractional order of the reaction. How you are going to do it now? Okay. Now order of the reaction, that is order is the same of the powers of the concentration. Powers of the concentration means if in case the 2 electrons are being given to someone, means how much will be my power right now? -2, right? I'm giving it to someone. Okay. Now if in case I'm a +2, it is there, then it means what? I'm taking it some amount, right? So this is the how is power. It means what? Concentration is going to increase when you are going to make the moles or a molar mass more and more, right? So this you should remember. So next, order of the reaction, that is sum of the powers of the concentration terms on which rate of the reaction actually depends on sum of the powers of the concentration terms in the rate law expression. In the what? In the rate law expression. Clear? In the rate law expression. Now, how we are going to express this in this form? So, H2 plus Cl2 is going to be what? In the H nu, that is going to be 2HCl. Clear? And next question comes 2N2O5, that is going to get what? 4NO2 plus O2. Next 2NO2 plus F2, that is going to be 2NO2F. Next, the saponification of esters also, how you are going to take the reaction in this form. Clear? CH3COO C2H5, done, plus NaOH, which is going to give us CH3COO sodium. Sodium hogi carbon jode attach agutte, avag CH3COO Na agutte, plus C2H5OH. The rate is going to be what? Rate is going to be K CH3COO C2H5 of 1 and NaOH, and it is going to be how much? NaOH. Clear? Same thing ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೇಮ್ ಥಿಂಗು ಇಲ್ಲಿ ಏನ್ ಫಾರ್ಮ್ ಆಗುತ್ತಲ್ಲ ಅದ್ರ ಬಗ್ಗೆ ರೇಟ್ ಅನ್ನ ಫೈಂಡ್ ಮಾಡ್ಬೇಕು ನಾವು. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ನಾವು 2NO plus O2 which is going to give us 2NO2, right? Balanced equation right now. Done. ಈಗ ರೇಟ್ ನಲ್ಲಿ ರೇಟ್ is equal to K NO2. NO2 ಎಲ್ಲಿದೆ? ರಿಯಾಕ್ಟೆಂಟ್ ಗೊತ್ತಾಯ್ತಾ? ಪ್ರಾಡಕ್ಟ್ O2. Clear? Which what it is getting reacted. Now what is the rate of it? 2 plus 1, that will be 3. That will be the third order reaction. Clear? So how you need to find the third order, second order, and you people got to know? Understood? ಹೇಗೆ ಅನ್ನೋದು ಗೊತ್ತಾಯ್ತಾ? ತಿಳಿತಲ್ಲ? Next question, that is define molecularity of the reaction and give an example for an unimolecular, bimolecular and trimolecular reaction. Okay, ಏನ್ ಮಾಡ್ಬೇಕು ಈಗ? ಡಿಫೈನ್ ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು. ಅದಾದ ತಕ್ಷಣ you need to tell us about examples of unimolecular, bimolecular and a trimolecular reaction. So the number of the atoms, ions or the molecules which are present that must collide with one another simultaneously. Okay, ಯಾವ collide ಅಂದ್ರೆ ಏನು? ಯಾವ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಮತ್ತು ions, ಇಲ್ಲೆಲ್ಲ ಏನ್ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಮತ್ತು ions ಇದೆ ಎಲ್ಲ ರಿಯಾಕ್ಷನ್ ಫಾರ್ಮ್ ಮಾಡೋದ್ ಮುಂದೆ ಅವೆಲ್ಲ collide ಚೆನ್ನಾಗಿ ಆಗಬೇಕು. If in case they are not colliding with each other properly, then the product we are not going to get it properly. Clear? So that's only they told collide with one another simultaneously. At a time it should be done. It's not like separately the atoms will be collided and the atoms will be separated, or ions will be separated, or molecules will be separated. No, all the things should be colliding with each other at once itself. Clear? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ರಿಯಾಕ್ಷನ್ O2F2 which is going to get O2 plus F2. The molecularity ಏನಾಗುತ್ತೆ? Molecularity is going to be 1 because it's a unimolecular reaction. It's a unimolecular reaction. Next 2HI which is going to give us H2 plus I2. There the molecularity will be how much? 2. For that purpose, we are going to name it as bimolecular reaction. Clear? So all are actually elementary reactions itself. All are going to be the elementary reactions itself. Yakappa elementary reactions irutte ella? Because molecularity find ಮಾಡೋದು ಹೇಗೆ, ಯಾವ ರಿಯಾಕ್ಷನ್ ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ಕೊಡ್ತಿದೆ ಅಲ್ಲ ಅದು ಮೇನು. ಓಕೆ, ಈಗ ರಿಯಾಕ್ಟೆಂಟ್ ನಲ್ಲಿ ಇನ್ ಕೇಸ್ ಯಾವುದೋ ಒಂದು ಅಟಮ್ ಇದೆ. ಓಕೆ, ಆ ಅಟಮ್ ಹೋಗಿ ಕಂಬೈನ್ ಆಗಿ ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡ್ತಿದೆ. ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ಸ್ ನಾಟ್ ಕೊಲೈಡಿಂಗ್ ಓನ್ಲಿ ವಿತ್ ಈಚ್ ಅದರ್ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ, ಇದು ಒಂದು ಪ್ರಾಡಕ್ಟ್. ಲೆಟ್ಸ್ ಟೇಕ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ದಿಸ್ ಎಲಿಮೆಂಟ್, ಇದೊಂದು ಎಲಿಮೆಂಟ್, ಇವು ಎರಡು ಈ ಮಾಲಿಕ್ಯೂಲ್ಸ್, ದೇರ್ ಆರ್ 2 molecules here in this atom, right? 2 molecules ಇದೆ, ಇಲ್ಲಿ 2 molecules ಇದೆ in one atom, right? Both the things should collide with each other at once. Simultaneously collide ಆಗಬೇಕದು, ಅವಾಗಷ್ಟೇ ಪ್ರಾಡಕ್ಟ್ ಫೌಂಡ್ ಆಗೋದು ನಮಗೆ, ರೈಟ್? So this is what you need to understand it first thing. Okay, next comes what? Write the difference between the order and the molecularity of the reaction. This is also most important asked question. Make sure you might receive it in your FA also. So study it properly. Okay, now write the difference between, first is we'll see about the order, and according to that only we will go into the molecularity also. Okay, order is the sum of the powers of the concentration terms in rate law equation. In the rate law equation, molecularity is what? Is the number of the molecules that must collide simultaneously. That must collide simultaneously results in the chemical reaction, which will result in the chemical reaction. Clear? Next, order can be 0 or a fraction. Order can be 0 or it might be a fraction also, no problem. Sometimes it is a half order reaction, one or first order reaction, second order reaction, ಆ ತರನು ಆಗಬಹುದು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಆಯ್ತಾ? ಮಾಲಿಕ್ಯುಲಾರಿಟಿ ಏನಾಗುತ್ತೆ? ಮಾಲಿಕ್ಯುಲಾರಿಟಿ cannot be 0 and cannot be fraction. Okay, ಫ್ರಾಕ್ಷನ್ ಇರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಮತ್ತೆ ಇದನ್ನು ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. Clear? Next, order ನಲ್ಲಿ ಬರುತ್ತೆ, it's an experimentally determined quantity, right? It is experimentally determined quantity. Next, in molecularity in ಬರುತ್ತೆ, number of the molecule in balanced chemical equation for a simple reaction. It's going to be the number of the molecules is actually going to be the balanced chemical equation and for the simple reaction. For the simple reaction. Clear? Next, order in ಬರುತ್ತೆ, order is significant for the simple and the complex reaction. For the simple and the complex reaction. For the molecularity, it is insignificant for the complex reaction. It's very insignificant for the complex reactions. Clear? Understanding? Understanding? Tilita? Next. Derive an integrated rate constant K for the zero order reaction. Okay, this is the small derivation. Yes, this is a small derivation. If you understand it very well, it will be clear to you people. Okay, it will be clear to you people when you understand it very well. Clear? Now consider the dental reaction, that is R to P, where suppose R0 is going to be considered as initial concentration. R0 is going to be considered as initial concentration of the reactant. Clear? And R is going to be the remaining concentration of the reactant at time. Reactant at time. Clear? So now T and K is the rate constant. T and K is going to be the rate constant here. Clear? Now rate K is going to be the R0, where concentrate we need to differentiate here. Okay, differentiate ಮಾಡಬೇಕಿಲ್ಲಿ K of R0. See, ಇದನ್ನ differentiate ಮಾಡಂತಲೇ ಏನಾಗುತ್ತಪ್ಪ? D of R, D of R. Okay, D of R. Let me write it down. Okay, ಇಲ್ಲಿ minus D is visible properly. No, I'll take a lighter version. Okay, minus D of R, clear, divided by dt, divided by dt, according to the T we are finding it. Okay, is equal to K of R0. This is equal to K of R0. E rate law na ಏನು ತಗೊಂಡಿದ್ದೇವಲ್ಲ, we are differentiating it. Okay, we are differentiating it. Clear? Then afterwards minus dr divided by dt is equal to K. Is equal to K. Now this D of R is equal to minus K dt. It's going to be what? Minus K dt. Clear? Understanding? So idain dr ideyalla, that is going to be the minus dt. So differentiate madidare according to the r. So that time what is going to be according to time, how much it is going to come? Minus k dt. So now yavaga iga left side means LHS ಮತ್ತೆ RHS side, both the side we are going to integrate it. Okay, when you are going to apply a integration on both the sides, we are going to get it as integration of d of r is going to be the minus k, which is a constant which is going to be outside, and integration of dt, that is going to be the dt. Now concentrate properly. When you integrate it, that is going to be r, that is rate, is equal to minus kt plus 1. That will be the equation 1 to us. Clear? That will be the equation 1 to us. Next, when you are going to consider time has going to be the 0 and r is going to be the r naught. So ನಾವು ಯಾವಾಗ ಟೈಮ್ ಅನ್ನ 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ವಿ, r ಅನ್ನ r naught ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ವಿ. ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದ ಥಿಂಗ್ಸ್ ಇನ್ ದ ಇಕ್ವೇಶನ್. ಓಕೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಎದರಲ್ಲಿ ಮಾಡ್ತೀರಾ? ಇಕ್ವೇಶನ್ 1 ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ, ಆಯ್ತಾ? ಸೊ ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ r naught is equal to minus k of 0. You know already it is going to be, time is going to be 0, right? Time is 0, I have substituted it, plus I. Then I is equal to r naught. It just idana ikkade togondi. That's it. Okay, don't get confused. R is equal to minus kt plus r naught, plus r naught. Let us consider as equation 2. Clear? So r is equal to minus kt plus r naught and the consider manakuna second equation. Now both the equation together, what we are going to get it? That is kt is equal to r naught minus r. R naught minus r. Clear? R naught minus r. Now we need to know the value of k, right? So ಅದಕ್ಕೆ k ಅಲ್ಲ just ಹಾಗೆ ಇಟ್ಕೊಳ್ಳೋದು, ಮತ್ತೆ ಇದೇನಿದೆ ಅಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಸೆಪರೇಟ್ ಆಗಿ ಬರೆದು ಬಿಡೋದು, ಆಯ್ತಾ? Divided by this t is gonna go down here. Okay, that will be t. Clear? So this is the equation, main equation. Clear? So this is going to be also asked for 4 to 5 marks. 4 to 5 marks they might ask this question. So be perfect with this question. Okay, perfect ಆಗಿರಬೇಕು ಈ question. Next comes the question, that is define half-life period, derive the half-life period for the zero order reaction. So half-life period andre enu, matte half-life period anna for zero order how much it will be, they have asked it. For zero order how much it will be, they have asked it. Clear? Understanding? Understanding? Yes. Good ma'am, good evening. Gundu ma'am, good evening. Purvaja, okay, hi. Yes, so define half-life period and derive, they have told us to half-life period for zero order reaction. Okay, the time in which the half of the substances reacted is called going to be half-life period. Means what? ಈಗ ಯಾವುದಾದ್ರು ಒಂದು ರಿಯಾಕ್ಷನ್ ಇದೆ, ಓಕೆ, ಆ ರಿಯಾಕ್ಷನ್ ಅರ್ಧ ಜಾಗದಲ್ಲಿ ಬಂದ ನಂತರ ಅದಕ್ಕೆ ಹಾಫ್ ಲೈಫ್ ಅಂತ ಕರೀತಾರೆ, ತಿಳಿತಾ? ಅದಾದ ತಕ್ಷಣ ಇನ್ನೊಂದು ಅರ್ಧ ರಿಯಾಕ್ಷನ್ ಮುಗ್ಲಿಕ್ಕೆ ಇನ್ನೊಂದು ಒಂದು ಇನ್ಫಿನಿಟಿನೇ ಬೇಕು, ಲೈಕ್ ವಿ ನೀಡ್ ಮೋರ್ ಅವರ್ಸ್ ಟು ಫಿನಿಶ್ ಅನದರ್ ಹಾಫ್. ಓಕೆ, ಈಗ ಅರ್ಧ ಮುಗಿಲಿಕ್ಕೆ ಹಾಫ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರೀತಾರೆ. ಒಂದ್ ಯಾವುದೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ಲಿಕ್ಕೆ half reaction is being done. That product to get half it has been reacted, still half the reactions needs to be done. Clear? So we know that already half-life period for the zero order reaction is going to be what? T half. Obviously we need half %, then it is going to be how much? T half, right? That will be T half. That is, we know that K is equal to A naught minus A divided by T. A naught ಬೇಡ ಅಂದ್ರೆ ನೀವು R ಅಂತಾನು ತಗೋಬಹುದು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಆಯ್ತಾ? So K is equal to what? K is equal to A naught minus A divided by T ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ವಿ. R ತಗೋಬಹುದು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಓಕೆ, ಸೊ T is equal to T half, we know it. A is equal to A naught, because we are finding the half life, we are going to take it as what? 1 by 2 itself. We are going to consider as 1 by 2 itself. Then T half is equal to 1 by K, that is going to be the A naught minus A naught divided by 2. Clear? So now we need to find the T half. No, we need to get the T half. So T half is also equal to 1 by K, is 1 by K, A naught minus A naught divided by 2, minus A naught divided by 2. 2. This whole thing, how you are going to change is T half is equal to A naught. A naught common takondvi divided by 2. EK I'll hogutte. Right? Okay, I'll change the box color now. Okay, that will be what? T half is equal to A naught divided by 2K. A naught divided by 2K. Clear? Done. Next. For zero order reaction, rate is independent of the initial concentration of the reactant, but half-life period is directly proportional to the initial concentration of the reactant. So for that purpose only, T half is equal to, okay, atir salvagine T half is equal to, okay, T half is actually equal to A naught. So it's directly proportional to A naught. Clear? So now what will be the reaction which you should remember in the zeroth order? Okay. ಈಗ ಅಕಸ್ಮಾತ್ ಯಾವಾಗಾದ್ರೂ zeroth ಈಗ ಕೇಳಿದರೆ zeroth order. zeroth order ಬಿಟ್ಟು first order ದು half life ಕೊಡಪ್ಪ ಅಂತಂದ್ರೆ ಈಗ ಎಲ್ಲೆಲ್ಲಿ half ಮಾಡಿದಾರಲ್ಲ write it as T1. That's it. Okay. D1 ಈಗ ಅಕಸ್ಮಾತ್ first order ಕೇಳಿದ್ರೆ T1 ಬರೆಯೋದು, half life ಕೇಳಿದ್ರೆ T half ಬರುತ್ತೆ. In second order ಕೇಳಿದ್ರೆ T2 ಅಂತ ಬರೀಬೇಕು. ಆಯ್ತಾ? This much people will write, then it's more than enough. Clear? Done? Next. Derive an integrated rate constant K for first order reaction in which the reaction occurs in the solution. If you are considering the general reaction like R of P which is there, suppose R naught is going to be the initial concentration of the reactant and R is going to be the remaining concentration, that is reactant, and time is going to be the T and K is going to be the rate constant, then first order reaction ಏನಪ್ಪ ಆಗುತ್ತೆ? First order reaction is going to be the KR1, right? KR1 and the first order reaction. Clear up? So this KR1 which is there, that we are going to consider it, and we are going to get the answer as D of R minus K dt. It's going to be what? D of R minus K dt. Clear? Next, when you integrate this, you need to integrate it. Okay, when you integrate it, we are going to get it as integration of R divided by R is equal to minus K of integration of dt. Clear? So when you are going to remove the integration and you are going to apply the ln there, you are going to get a ln R is equal to minus kt plus ln of R. Okay, delta integration of the K of dt is going to be how much? Ln R2. Done? That we are going to consider as equation 2. That we will consider as equation 2. So Kt is equal to ln of R naught divided by R. That will be equation 3. Done? So K is equal to 2.303 divided by T log of R naught divided by R. ತಿಳಿತಾ? ಸೊ ಜಸ್ಟ್ ಏನ್ ಮಾಡಿದೇವೆ, ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ ಇದನ್ನ ಇಕ್ವೇಶನ್ ಅನ್ನ ಫೈಂಡ್ ಮಾಡಿದ್ದೇವೆ. ಕ್ಲಿಯರಾ? ಸೊ ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟು. ಓಕೆ, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಇಂಪಾರ್ಟೆಂಟ್. ಆನ್ ದಿಸ್ ಓನ್ಲಿ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಅ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಲ್ಸೋ. ತಿಳಿತಾ? ಸೊ ಈ ಇಕ್ವೇಶನ್ ಮೇಲೆ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಸಿಗುತ್ತೆ. ಸೊ ಕಾನ್ಸಂಟ್ರೇಟ್ ಪ್ರಾಪರ್ಲಿ. ಈಗ ಫರ್ದರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಅಬೌಟ್ ದ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆಲ್ಸೋ. ಕ್ಲಿಯರ್? ಅಂಡರ್ಸ್ಟುಡ್ ವಿತ್ ದಿಸ್? Yes. Next we are going to go derive integrated rate constant for the first order reaction. I have told you already this. Zeroth order in find ಮಾಡಿದೇವಲ್ಲ, ಸೇಮ್ ಅದೇ ತರ ಫಸ್ಟ್ ಆರ್ಡರ್ ಅನ್ನು ಫೈಂಡ್ ಮಾಡ್ಕೋಬೇಕು. ಆಯ್ತಾ? Next question, derive half life period for the first order reaction. For the first order reaction you need to find the zeroth order. Okay, now half life period for the first order reaction is going to be how much? ಈಗ ನೀವು T half find ಮಾಡಿದ್ವಿ, half life ಅನ್ನ find ಮಾಡಿದ್ವಿ. ಈಗ ಸೇಮ್ ಅದೇ ತರ first order find ಮಾಡಬೇಕು. Okay, so wherever you are going to add the half, that you are going to remove it and put it as 1. That the initial value how much it will be? That will be T half is equal to 0.693 divided by K. Okay, done? Yes. Next, what is zero first order reaction? Give an example. Okay, a chemical reaction is of second order but under specific conditions behaves as first order reaction are going to be the zero first order reaction. So yav chemical reactions ideyalla, those all chemical reactions is a second order, but they all are going to be the second order, but under specific condition, which will behave as a first order reaction, that is going to be the zero first order reaction. Examples ಏನು ತಗೋಬಹುದು? So ಈಗ ನೋಡಿ examples ಏನು ತಗೋಬಹುದು? CH3COO C2H5 which is reacting with the H2O, which is reacting with water. We are going to get CH3COOH plus C2H5OH. Okay, this is going to get reacted with the OH. Clear? So this is going to be what? Acid hydrolysis of ester. Now we already know the rate about the rate, right? So the rate is equal to K of CH3COO C2H5, okay, CH3COO C2H5 and H2O. Clear? First order reaction ಮತ್ತೆ zeroth order ಯಾವ್ದು ಬರ್ತಂತ ಫೈಂಡ್ ಮಾಡ್ಕೋಬೇಕು. Done? Now next comes same thing, ಇನ್ನೊಂದು equation ಕೊಟ್ಟಿದ್ದಾರೆ which is about the sucrose. Okay, first esters ಇದು ಮತ್ತೆ ಒಂದು sucrose ದು. One example is more than enough. They have not told you to write the many examples, like 4-5 examples ಹೇಳಿಲ್ಲ, one example ಹೇಳಿದ್ದಾರೆ, it's enough to draw the write the one example. Clear? So next question, what are the effects of catalyst on the rate of reaction? What is the work of the catalyst it is doing? So ನಾನು ಬದಲು ಹೇಳಿದೆ ನಿಮಗೆ ಸ್ಟಾರ್ಟ್ ಆಫ್ ದ ಲೆಸನ್ ಅಲ್ಲಿ, ಐ ಥಿಂಕ್ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ catalyst ಅನ್ನೋದು ಬಂದಿತ್ತು. ಸೊ ಅಲ್ಲಿಯೂ ಹೇಳಿದ್ದೆ, ಐ ಆಲ್ ರಿಪೀಟಿಂಗ್ ಇಟ್ ಒನ್ಸ್ ಅಗೇನ್. Catalyst work is what? To make the reaction faster and make the reaction. If we want it in a slow wise, we can make it in a slow wise also. So catalyst salvagi ಏನ್ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ it's a extra worker to us. Okay, it's a extra worker to us. ಈಗ ನೋಡಿ, ನೀವು ಸ್ಕೂಲ್ ನಲ್ಲಿ ಹೋಗಿಲ್ಲ, ಇಲ್ಲ ಕಾಲೇಜ್ ನಲ್ಲಿ ಹೋಗಿ ಕಲ್ತು ಬಂದಿರ್ತೀರ. ಓಕೆ, ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಫುಲ್ ಚಾಪ್ಟರ್ಸ್ ನ ಕಲ್ತಿರ್ತೀರ. ಆ ಚಾಪ್ಟರ್ ನ ಯಾವಾಗ ಕಲಿತಿರಲ್ಲ, ಇನ್ನ ನಿಮಗೆ ಸಪೋರ್ಟ್ ಬೇಕಲ್ಲ, ಸೊ ಯು ವಿಲ್ ಕಮ್ ಟು ಹಿಯರ್. ಓಕೆ, ನೀವು ಇಲ್ಲಿ ಒಂದ್ ಸ್ವಲ್ಪ ಕಲಿತೀರಾ, ರೈಟ್, ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಸಪೋರ್ಟ್ ಸಿಗುತ್ತೆ, ಸೊ ಇನ್ನೊಂದ್ಸಲ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ ಮೋರು, ರೈಟ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತಲ್ಲ, ಡಬಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಏನಾಗುತ್ತಲ್ಲ, ಅದರಿಂದ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ನೊಂದ್ ಸ್ವಲ್ಪ ತಲೆಯಲ್ಲಿ ಉಳಿಯುತ್ತೆ, right? So same way the catalyst is also like a third person which is helping us to get the product in a proper way, okay. A catalyst is a substances which increase the speed of the chemical reaction and without itself undergoing any chemical changes. So ಈಗ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ, okay, it's not changing any chemical reaction. It's going to be the same, okay, reaction is the same irutte, just the thing is reaction ana fast maduttadu, aita, it will make it faster, that's it. Okay, 2 KClO3, that is in the presence of heating and by MnO2, we are going to get it as 2 KCl plus 3O2. Clear? Understanding? Next, characteristics of the catalyst. ಏನಪ್ಪ characteristics ಇದೆ catalyst do? A small amount of a catalyst is sufficient to bring the large number of the reactions. We are going to get it by the small number of catalyst also. ಸ್ವಲ್ಪ catalyst ಯೂಸ್ ಮಾಡಿದ್ರೂ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಮಾಡ್ಲಿಕ್ಕೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗಲ್ಲ. It's not like we need a huge amount. ಎಷ್ಟು reactant ತಗೊಂಡಿದ್ದೇವಪ್ಪ, ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬೇಕಿದೆ, ಅಷ್ಟೇ catalyst ಯೂಸ್ ಮಾಡ್ಬೇಕಂತ ಏನೂ ಇಲ್ಲ. We can use the small amount also, depends on what product we want, okay, and how much faster we want, that is also main. Okay, next, a catalyst does not alter free energy changes, that is delta G, and enthalpy changes in the composition, and the catalyst does not alter the position of equilibrium, but also it helps to attain the equilibrium quickly. Means what? Catalyst's work is what? To make the reaction faster. That will be done, but the reaction changes nothing will happen, okay, adu ಏನು changes ಆಗಲ್ಲ. Clear? Next, write the graphical representation for the effect of the catalyst on the rate of the reaction. Okay, graphical representation on the effect of the catalyst on the rate of the reaction. Okay, this is the reaction profile which is there and the potential energy which is present. Clear? So here what is going to happen is, according to, if in case you are increasing the catalyst, okay, okay, ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀರಾ, without the catalyst, what will be the reaction profile? You can check it. And with the reaction profile, means with the catalyst, what will be the reaction? Clear? So this is what you need to understand. Next, mention 2 conditions for the effective collision. They have told, first one is proper orientation of the reactants, it should be there, and a threshold energy should be there. Clear? Okay. Next question. Okay, next chapter we are going to go for the coordination compounds. Next chapter we are going to go for coordination compounds. Clear everyone with the chemical kinetics? Clear with the chemical kinetics? Chemical kinetics clear aita ellargu? Understood everyone with chemical kinetics? Done. Let's move with the coordination compounds now. Okay, yare coordination compounds ide FA fast agi ಹೇಳಿ ನೋಡೋಣ. So write the difference between the double salts and the coordination compounds. So chemical kinetics in the first order to second order reactions and explanation of the zeroth order, first order, second orders was very important. So yav tara questions ana keltare matte yav bahal repeat agide avella questions ana explain madidene chemical kinetics du, and now we are going to go for the coordination compounds. Clear? So in coordination compounds, most probably the asked questions are like double salt and what about the coordination compound and how to solve those things. Those all things will be asked. Let us check it out. Okay. Double salts versus coordination compounds. Now double salts are ಏನಪ್ಪಾ? Double salts are the ionic compounds. Double salts are the ionic compounds. Okay, are the ionic compounds and do not contain any coordinate bond. They do not contain any coordinate bond. And coordination compounds are complex salts, may or may not be ionic, but always contains the coordinate bonds. Clear? So coordination compounds only yavaglu coordinate bonds irutte, but double salts nalli coordinate bonds iralla. Double salts nalli coordinate bonds iralla. Done. Next, double salts is stable only in the solid state. It is stable only in the solid state. Clear? So solid state ashte double iruttadu. Done. But dissociate into simple ions completely in the solution state. But it will dissociate completely. It will dissociate completely into the simple ions completely in the solution state nalli iddaga. Okay. Solution state iddaga simple ions ana completely dissolve ಮಾಡುತ್ತೆ. Clear? Next, complex salt is a stable both in solid and solution. Okay. Complex salt stable nallinu irutte ಮತ್ತೆ solid ಮತ್ತೆ solution nallinu completely dissolve ಆಗುತ್ತೆ. Clear? And dissociate completely in the solution state. That's what I told you. Double salts nalli the properties of the double salts are same as their consistencies. Okay, same as their consistencies. Next, coordination compound nalli the properties of the complex part is quite different from their consistencies. Clear? So ilenagutte the properties of the complex part is quite different from the consistencies, but in the double salts the properties of the double salts will be what? Same as their consistencies. Okay, consistency ಎಷ್ಟು ಇರುತ್ತೆ ಅಷ್ಟೇ ಇರುತ್ತೆ. Clear? Understanding? ಎಷ್ಟು ಮಂದಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಿಲ್ಲ? ಫಾಸ್ಟ್ ಆಗಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಿ ಎಲ್ಲರೂ. ಹೋಗಿ ಎಲ್ಲ ಫ್ರೆಂಡ್ಸ್ ಅನ್ನ ಕರ್ಕೊಂಡ್ಬರಿ. FA ಎಲ್ಲ ಎಕ್ಸಾಮ್ಸ್ ಪಾಸ್ ಆಗೋದೇನಿಲ್ಲ, ಎಲ್ಲರಿಗೆ ಪಾಸ್ ಆಗೋದೇನಿಲ್ಲ, ಎಲ್ಲರಿಗೆ FA ಎಕ್ಸಾಮ್ಸು. ಫಾಸ್ಟ್ ಆಗಿ ಹೋಗಿ ಎಲ್ಲ ಫ್ರೆಂಡ್ಸ್ ಅನ್ನ ಕರ್ಕೊಂಡ್ಬನ್ನಿ. Let us learn it together. Next, what are bidendant or didendant ligands? Give examples. So on ligands, coordination compounds nalli fix ಮತ್ತೆ short question ಬರ್ಕೊಂಡು ಇಟ್ಕೊಂಡ್ಬಿಡಿ. ನಾನು ಯಾವ್ದು ligands ಬಗ್ಗೆ ಕ್ವಶನ್ಸ್ ಕೊಡ್ತಿದ್ದೇನಲ್ಲ ಅವತ್ತದೆಲ್ಲ ಸ್ಕ್ರೀನ್ ಶಾಟ್ ಹೊಡ್ಕೊಳ್ಳಿ, ಬರ್ಕೊಳ್ಳಿ ನೋಟ್ಬುಕ್ ಇದ್ರೆ. ಸೊ ಇವೆಲ್ಲ ಕ್ವಶನ್ ಶಾರ್ಟ್ ಆಗಿ ಬೀಳುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ವಾಟ್ ಆರ್ bidendant or didendant ligands? Give example. So this ligands which contain two donor atoms, which contains the two donor atoms can form the two coordinate bonds. It can form the two coordinate bonds with a central metal atom or ion. Clear? So ಏನಪ್ಪ ligands? Be active in the chat box everyone. So ligands which contain two donor atoms, which will contain what? Two donor atoms will be present. Clear? So and can form the two coordinate bonds. Two coordinate bonds form ಆಗುತ್ತೆ ಮತ್ತೆ two donor atoms ಇರುತ್ತೆ. Clear? Two donor atoms also will be present and two coordinate bonds also with central metal atom will be present. Example, NH3, NH2, CH2, CH2, NH2. This is going to be the ethylene diamine. Ethylene diamine. Same example here, COO minus, COO minus oxalate ion. This all are the ligands. These are bidendant and didendant ligands which will be connected to the coordinate compounds. Clear? Next, what are polydendant ligands? ಈಗ ನಾವು ಸಿಂಗಲ್ ಕಲ್ತ್ವಲ್ಲ, ಡಯೋ ಸಿಂಗಲ್ ಅಂದ್ರೆ ಟ್ರೈ, 3 ಅಂದ್ರೆ ಟ್ರೈ ಲಿಗೆಂಡು, ಸಿಂಗಲ್ ಅಂದ್ರೆ ಡೈಡೆಂಡೆಂಟ್ ಲಿಗೆಂಡು, ಆ ತರ. ಓಕೆ, ಪಾಲಿಡೆಂಟ್ ಅಂದ್ರೆ ಏನು? ಮೂರಕ್ಕಿಂತ ಜಾಸ್ತಿ ಎಲ್ಲದಕ್ಕೂ ಪಾಲಿಡೆಂಡೆಂಟ್ ಲಿಗೆಂಡ್ ಅಂತ ಕರೀತಾರೆ. ಆಯ್ತಾ? ಲಿಗೆಂಡ್ಸ್ ವಿಚ್ ಕಂಟೈನ್ ಮೋರ್ ದೆನ್ 2 ಡೋನರ್ ಆಟಮ್ಸ್. It contains what? More than 2 donor atoms and can form more than 2 coordinate bonds also with central metal atom or ion. With the central metal atom or a ion is called as what? Polydendant ligands. We can take the examples as what? NH2, CH2, CH2, NH. This is going to be the central atom, and CH2, CH2, NH. That is going to be the diethylene triamine. Clear? Yes. Next, what are ambidendant ligands? ಈ ಮೂರು ಕ್ವಶನ್ ಅಲ್ಲಿ ಶಾರ್ಟ್ ಆಗಿ ಒಂದ್ ಕ್ವಶನ್ ಬಿದ್ದೇ ಬೀಳುತ್ತೆ. ಪಾಲಿಡೆಂಟ್ ಆದ್ರೂ ಕೇಳಿದ್ದಾರೆ, ಎಂಬಿಡೆಂಟ್ ಅಂತೂ ಜಾಸ್ತಿ ಕೇಳಿದ್ದಾರೆ. ಮೋರ್ ದೆನ್ ಪಾಲಿಡೆಂಟ್, ಎಂಬಿಡೆಂಟ್ ದೇ ಹ್ಯಾವ್ ಆಸ್ಕ್ಡ್ ಅ ಲಾಟ್. ಓಕೆ, 2 marks ಕ್ವಶನ್ ಇದು. This is 2 marks question. Okay. Next, ligands which have 2 or more donor atoms can bond to central metal atoms or ions through only on donor atoms are called as ambidendant ligands. Clear? Through donors is called as ambidendant ligands. Means what? ಯಾವ್ಯಾವ ligands ನಲ್ಲಿ 2 ಮತ್ತೆ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ donor atoms ಇದೆ, ಅದಕ್ಕಿಂತ 2 ಮಿಂತಕ್ಕಿಂತ ಜಾಸ್ತಿ donor atoms ಇದೆ, and ಇದು ಬಾಂಡ್ ಆಗೋದು ಎದ್ರ ಜೊತೆ? ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಜೊತೆ ಬಾಂಡ್ ಆಗ್ತಿದೆ, and the ions are going through only the donor atoms. Ions ಎದ್ರ ಜೊತೆ ಹೋಗ್ತಿದೆ? It's going through only donor atoms. Okay, that is going to be what? Ambidendant ligands. Clear? So first example we can take it as NO2, which is giving us nitro, that is N, which is going to give us nitro O. So these are the few examples which you can take it. Clear? Next, define coordination number, give an example. This also has been asked. Okay, idnu bala sala kelidare 2 marks ge. Okay. Next, the coordination number is actually the number of the coordination bonds formed by the central metal atom or ion with the ligand. Clear? So, the coordination number is actually the number of coordination bonds formed by the central metal atom. Okay, central metal atom ದಿಂದ coordination number it form ಆಗುತ್ತಲ್ಲ, ಅದಕ್ಕೆ coordination number ಅಂತ ಕರೀತಾರೆ. Clear? So you will understand it when we solve the problem. Okay, don't worry. So next, complexes ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ ನೋಡಿ. ಹೇಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕಂತ? PlCl6 2+. Okay, this is the example. coordination number ಏನಾಗುತ್ತೆ? 6. Done. Next, same ಅದೇ ತರ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಇಲ್ಲಿ ಏನಿದೆ? NH4, NH3 4, En3 6 because it is 3+. Clear? Next, what is homolytic complex? Give example. And homolytic complexes are the complexes in which the central metal ion or an atom is being bound to only one type of a donor groups. It's a bond only to the one type of a donor groups. Okay, donor groups one type ide. Clear? So ligands, example, K4FeCN6. Understanding? Okay, what is heteroleptic complex? Homoleptic, heteroleptic. These are all 2 marks, 1 marks questions. Okay, options nallinu ಕೇಳಬಹುದು. Okay, heteroleptical complexes are the complexes in which the central metal atom or a ion is being bound more than one type of donor group. Okay, ಅದು ಎದರ ಜೊತೆ ಬಾಂಡ್ ಆಗಿರುತ್ತೆ? one type of donor, more than one type of donor group ಜೊತೆ ಅಟ್ಯಾಚ್ ಆಗಿದ್ರೆ ಅದಕ್ಕೆ heteroleptic donor ಅಂತ ಕರೀತಾರೆ. homolytic ಏನು? one type of donor ಜೊತೆ. Okay, one type of donor ಜೊತೆ ಅಂದ್ರೆ homoleptic. ಅಕಸ್ಮಾತ್ ಜಾಸ್ತಿ one time ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ heteroleptic. Clear? Next, explain how ionization isomerism with an example. So ionization isomerism with an example. So coordination compound having the same molecular formula. Okay, coordination compound which is having the same molecular formula but produces different ions. It will produce the different type of ions when dissolved in the water. When it has been dissolved in the water is going to be the ionization isomers. It is going to be what? Ionization isomers. Clear? And phenomenon is going to be ionization isomerism. So a phenomenon, a process gain karitare ionization isomerism anta karitare. Clear? Examples. These are the two examples which you can go through. Clear? Now, first complex produces SO4 2 minus ion. First complex will produce SO4 2 minus ion when dissolved in the water. When it is being dissolved in the water. But the second complex produces Br minus. But the second will produce what? Br minus ion produce madutte. Clear? And then when it is dissolved in the water. When it is being dissolved in the water. Clear? Understanding? First complex produce ಏನು ಮಾಡುತ್ತೆ SO4 2 minus produce ಮಾಡುತ್ತೆ. Second to Br minus ions produce ಮಾಡುತ್ತೆ. Clear? Understanding? Be active in the chat box everyone. No one is telling me hi. Fast. Yes. Next. Explain linkage isomerism with an example. Linkage isomerism with an example. Coordination compounds having the same molecular formula but different mode of attachment. The mode of attachment will be different. Okay. Coordination number ge, coordination compound ge having the same molecular formula. Okay. Molecular formula same irutte. But concentrate properly. Molecular formula will be same. But it will differ in the mode of attachment. It will differ in the mode of attachment of ambient ligand and central metal ion are called as linkage isomers. It is called as what? Linkage isomers. Clear? Understanding? Be active in the chat box everyone. Yes, fast. Yes, ambience coordination compounds ge molecular formula same irutte. Okay, molecular formula will be same but there will be a different in the mode of attachment. Adakke molecular formula ge attachment different irutte. Mode of attachment will be completely be different and on the central metal ion and is called as linkage isomerism. That is also definition called as linkage isomerism and the phenomenon is going to be called as what? Linkage isomer. It is called linkage isomer. Clear? Consider a coordination compound containing an ambident ligand that is NO2. Okay, we have considered as a ligand that is NO2 minus. Okay, in consider madkona coordination compound tagolana. This is having an ambience of how much? Ligand of NO2 minus. Done. So it can coordinate with the central metal ion through oxygen or nitrogen atom. Through the oxygen or nitrogen atom. Example, concentrate. This is very important to understand the example here. Illodi, this example kottidare. Okay, that is CONO, that is NH3 5Cl2. Clear? Concentrate. Now, this formula idella, this central metal atom papa ligands ivella enidella yav through hobeku, hegappa hobeku. So idradu molecular formula ella same irutte. Attachment in ಮಾಡ್ತೇವಲ್ಲ ಅದು ಡಿಫರೆಂಟ್ ಹಾಕೋತ ಹೋಗುತ್ತೆ. ಸೇಮ್ ಅದೇ ತರ ಇಲ್ಲೂ ಸೇಮ್ ಇದೆ ಬಟ್ ಹಿಯರ್ ದ ಅಟ್ಯಾಚ್ಮೆಂಟ್ ಇಸ್ ಡಿಫರೆಂಟ್. ಕ್ಲಿಯರ್? ಸೊ ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಕಾಲ್ಡ್ ಆಸ್ ಅ coordination isomerism. Clear? This is very important. They have asked a lot of time this question. Okay, bada important question idu. Important means what? I am telling you very important. Short ಆಗಿ ನಿಮ್ಮ FA ನಲ್ಲಿ ಬಂದ ಬೀಳುತ್ತದು. Okay, if this thing will not come in the FA, come and tell me. Okay, short ಆಗಿ linkage isomerism ಬಗ್ಗೆ ಕೇಳ್ತಾರೆ. They will tell you to explain it. If you are knowing the linkage isomerism, fast ಆಗಿ chat box ನಲ್ಲಿ ಹೇಳಿ. Let's see how many people have understood it and how many people are learned it already. ಎಷ್ಟು ಮಂದಿ ಕಲ್ತಿದಾರ ನೋಡೋಣ ಹೇಳಿ linkage isomerism ನ ಫಾಸ್ಟ್ ಆಗಿ. linkage isomerism ಎಷ್ಟು ಮಂದಿ ಕಲ್ತಿದಾರ ಮತ್ತೆ ಶಾರ್ಟ್ ಬರುತ್ತೆ, ಎಷ್ಟು ಮಂದಿ ಓದಿದ್ರಿದ್ನ? Yes, tell fast. Next, explain solvent or hydrate isomerism with an example. So coordination compounds which are having a same molecular formulas. Molecular formula will be same but different in the number of molecules of a solvent. Ali mode of attachment ittu ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಸಾಲ್ವೆಂಟ್ or hydrate isomerism ನಲ್ಲಿ ಈಗ hydrate isomerism ನಲ್ಲಿ molecular formula same ಇರುತ್ತೆ okay same molecular formula but there will be a different in the number of molecules of a solvent has a ligands okay has a ligands number of the solvent molecules will be different has a solvent molecules will be different clear that is called as solvent isomerism or hydrated isomerism and it is also be considered as a very important why okay so whenever the solvent is in water ಯಾವಾಗ solvent ನೀರಿನಲ್ಲಿ ಇರುತ್ತೆ ಅದಕ್ಕೆ ಏನು ಕರೀತಾರಪ್ಪ hydrated isomerism ಅಂತ ಕರೀತಾರೆ hydration ಯಾವಾಗ ಆಗುತ್ತೆ when hydrogen is present inside it right so now the compound with a molecular formula CrCl36H2O can form the 3 hydrate isomerism as follows okay ಈ compound ಇಂದ okay CrCl36H2O because it is a hydrated isomerism clear so ಈ hydrated isomerism ಇಂದ 3 formation ಆಗುತ್ತೆ okay there will be through 3 hydrate isomerism will be formed which is that CrH2O6Cl3 that is going to be the hexaquochromium 3 chloride and one more is chromium H2O 5Cl2H2O that is going to be what that is pentaquochlorium chromium 3 chloride monohydrate one more is CrH2O4Cl2Cl2H2O clear so explain ಮಾಡಬೇಕು first hydrate isomerism ಅನ್ನ ಮತ್ತೆ ಆಮೇಲೆ examples ಕೇಳಬೇಕು so this most probably they have not asked the examples much but they have asked a definition a lot of times okay definitions ಅನ್ನ ಜಾಸ್ತಿ ಸಲ ಕೇಳಿದ್ದಾರೆ ಆಯ್ತಾ next explain the coordination isomerism with an example coordination isomerism with an example now coordinate isomerism is a type of isomerism due to the interchange of the ligands between the cationic and anionic entities of different metal ions present in a complex which is present in the complex clear examples CONH36 and CrCN6 and CrNH36 and CN6 clear so this is the coordination isomerism with an example clear in ನೆನಪಿಟ್ಕೋಬೇಕು interchange of the ligands between the cationic and anionic entities interchange ಆಗ್ತಿರುತ್ತೆ ಎತ್ತರದ್ದು interchange of ligands will be happening in between the cationic ಮತ್ತೆ anionic ನಡುವು ಆಯ್ತಾ next write the facial and meridial isomerism of a CONH33NO2 3 so this is going to be the facial isomerism and meridian isomerism so this is also been asked a lot of times this is also very very important it has been asked a lot of times okay bala sala repeat agiro question very very important so how you need to draw it you have written it here structure if you want you can take the screenshot also okay screenshot ಅನ್ನು ತಗೋಬಹುದು next question write the postulates of Werner's theory of coordination compound okay so in a coordination compound a central metal atom or an ion has 2 types okay it has how much 2 types of valencies so they are primary valency and secondary valency okay this coordination compound which is at the central metal atom it has a 2 valencies first is about the primary valency one more is about the secondary valency clear so the primary valency is ionizable and variable it's ionizable and it's been variable also but primary valencies are satisfied by a negative ions so ella primary valencies yav ide alla primary valencies they are all satisfied by the negative ions. Clear? Now secondary valencies are non-ionizable. It's completely ionized agalla. Clear? And it has been fixed, and secondary valencies are satisfied by the ligands. Satisfied by the ligands itself. Clear? Next, the number of the secondary valencies of the central metal atom or ion is equal to the coordination number. It's equal to what? Coordination number. And the secondary valencies are directed in the space around the central metal ion or atom. So, the geometry of the complex will depend on the orientation of the secondary valencies in the space. Secondary valencies in the space. Clear? Understanding? Be active in the chat box, everyone. Understanding it? ಹೇಳಬೇಕಲ್ಲ ಅದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು. Yes. Next one. So using VBT, explain the type of hybridization, geometry and magnetic property of CONH36 3+. CONH36 3+. This is also important, guys. Most repeated question. Okay. It's intadra melantu short one question bande barutte. Short ado. Need to learn. Okay. Need to learn this question. So electrical configuration of CO is going to be the AR3D746. So now first to CO do complete electronic configuration na understand ಮಾಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ ಆಯ್ತಾ. So first in ಬರುತ್ತಪ್ಪ ಅದರದು argon, that is 3D746. Electronic configuration of CO3+. 3+ ಇದೆ already ಇದರದು ಇಲ್ಲಿ done. Okay, that 3+, that is going to be the 3D6 4s0 4s0. Clear? Understanding? Be active with the chat box, everyone, fast. Okay. Next, orbitals of CO3+ ion are, how you are going to distribute it now. So in D, we have a D shell mein, we have almost 7 electrons. Clear? How I am going to distribute it now into the 7 electrons. So 1, 2, 3, 4, 5, 6. Clear? Next, in CO3+, how much it is there? I have substituted 6. 6, done. Then 4s2, s is going to be the 0 itself, nothing is present in it. Now when the strong ligand NH3 approaches, so yavaga ee cobalt, that is CO3+ ge NH3 approach madutte, yavaga NH3 approach madutte. So when it is going to get approached, that time the CO3+ ion, which is a pairing of the electron, which will take place in 3D orbital, which is occurring against the Hund's rule, okay, which we are occurring against the Hund's rule. Now concentrate properly how to find the hybridization of it. Okay, now we have found 3D alli enideyappa yava pairs ಮಾಡ್ಕೊಂತ ಹೋಗೋದು, direct pair ಮಾಡ್ಕೊಂತ ಹೋಗೋದು. This thing which is there, it will get jumped from this electron to this orbital, from this orbital to this orbital. This is how the pairings will be done. Now this is the remaining thing. Done. This is the remaining thing. D alli ಎಷ್ಟಪ್ಪ ಉಳಿದಿದೆ? 2 ಉಳಿದಿದೆ. How much it will be? D2, right? Oh sorry. D ನಲ್ಲಿ 2 ಉಳಿದಿದೆ, D2. Done. 2 ಉಳಿದಿದೆ, 1 2. Done. Next afterwards 4s. 4s ನಲ್ಲಿ ಎಷ್ಟು ಉಳಿದಿದೆಪ್ಪ? Nothing is remaining here, right? Then how much it will be? Yes will be how much? Nothing. Done. Next comes the 4p. 4p ನಲ್ಲಿ ಎಷ್ಟಿದೆ? 3 columns ಇದೆ, right? So 3 ಖಾಲಿ ಇದೆ, 3. Done. D2sp3. D2sp3 will be the hybridization, and the 6 hybrid orbitals, that is overlap with the orbitals with the 6 NH3 ligands. So 6 is the thing. This is the 6 with the ligand which has been attached. There is 6 electrons are present. Sorry, 6 ligands are there, where it is there, and it is going to overlap with that. Clear? Now next thing, D2sp3 antu aitu, hybrid orbitals aitu, ella aitu. Now thus the complex has the octahedral geometry. You know already, if in case it is a D2sp3 or D2sp6, it is going to be the octahedral geometry, which we already know it. ಓಕೆ, ನಾರ್ಮಲ್ ಕ್ಲಾಸ್ ನಲ್ಲಿ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ ಒನ್ ಶಾಟ್ ಆಲ್ರೆಡಿ ವೇದಾಂತ ಕರ್ನಾಟಕದಲ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೇವೆ, ಹೋಗಿ ಚೆಕ್ ಮಾಡಿ. ಅದರಲ್ಲಿ ಒಂದು ಸ್ಮಾಲ್ ಬಾಕ್ಸ್ ಕೊಟ್ಟಿದ್ದೇನೆ ನಾನು. ಓಕೆ, ದಟ್ ಬಾಕ್ಸ್ ವಿಚ್ ಇಸ್ ದೇರ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಅಪ್ಲೈ ಇಟ್ ಹಿಯರ್. ಇನ್ ಕೇಸ್ sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇದ್ರೆ ಏನಪ್ಪಾ ಜಾಮಿಟ್ರಿ ಬರುತ್ತೆ ಅನ್ನೋದು ಎಲ್ಲ ಡೀಟೇಲ್ ಆಗಿ ಆ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹಾಕಿದ್ದೇನೆ. ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, thus the complex has a octahedral geometry and it has no unpaired electrons and hence it is a diamagnetic. ಕ್ಲಿಯರ್? ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಯಾವು ಇಲ್ಲಿ ಅದರ ಸಲುವಾಗಿ ಅದಕ್ಕೆ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂತ ಕರೀತಾರೆ. ದೋಸ್ ಆಲ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ವಾಟ್? ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಕ್ಲಿಯರ್? Next, this complex uses inner d orbitals, that is 3d, inner d orbitals which is going to be the 3d for hybridization, for the hybridization purpose. Now hence it is the inner orbital complex. The inner orbital complexes are also called as spin paired complexes. In case yavadadru inner condition idre, you need to understand that spin paired complexes anta, or also a low spin complexes, low spin complexes. If in case no unpaired electrons are the diamagnetic, paired electrons is the paramagnetic, and according to the hybridization the geometry will be easily getting it. Clear? Easily gottagutte yaವಾಗ ನೀವು geometry ಬಗ್ಗೆ ಹೇಳ್ತೀರಾ ಅವಾಗ. Clear? Next, coordination compound. Next question. Using VBT, explain the type of hybridization, geometry and the magnetic property of COF6 3 minus. COF6 3 minus. Clear? Let's learn it then. Okay, so electronic configuration first ಬರ್ಕೋಬೇಕು. electronic configuration ಆದ ತಕ್ಷಣ ಅದನ್ನ ಹೇಗೆ electrons distribute ಆಗ್ತಿದೆ ಅನ್ನೋದು ಫಸ್ಟ್ ಬರ್ಕೋಬೇಕು. ಅದ್ ಆದ ತಕ್ಷಣ you need to find that whether the paired electrons and unpaired electrons are present or no. Okay, electronic configuration of CO is what? AR 3D4, AR 3D7, 4S2. Done. So now electronic configuration of CO3 plus is what? AR 3D6, 4S not. Clear? 4S not. Done. Now you are going to distribute that in the 3D, 4S, 4P and 4D. Done. So now in 3D that is going to be what? In 3D what is going to be that? This is the concept. Clear? Understanding it how you are going to get it. So ಇಲ್ಲಿ ಎಷ್ಟು ಇರಬೇಕಪ್ಪ? D electron ಅಲ್ಲಿ 6 ಇದೆ. Okay, 1 2 3 4 5 and 6. Done. 1 2 3 4 5 and 6. Clear? Now next comes 4s ಅಲ್ಲಿ ಇದೆ. 4s ನಲ್ಲಿ ಏನು ಇಲ್ಲ, the 0 it is, 0 it is, that 0 we have written it. 4p ಮತ್ತೆ 14 ನಲ್ಲಿನೂ ಏನು ಇಲ್ಲ. Now next is what? Yes, we will solve the model question paper also very soon. Okay, model question paper solving fast ಆಗಿ ಬರುತ್ತೆ ಡಿಸೆಂಬರ್ ನಲ್ಲಿ, ಡೋಂಟ್ ವರಿ. ಓಕೆ, ನಿಮ್ ಸಲುವಾಗಿದೆ ಪ್ರಿಪರೇಟರಿ ಸಲುವಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ತೇವೆ, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, ಕಾನ್ಸಂಟ್ರೇಟ್ ನಾವು. ವೆನ್ ವೀಕ್ ಲಿಗಂಡ್ F approaches the CO3 plus ions, it undergoes sp3d2. how ಯಾಕಪ್ಪ sp3d2 ಆಗುತ್ತೆ ಅನ್ನೋದು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. ಈಗ ನೋಡಿ, P D electron ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? How much it is there present? According to that you should check it. Okay, ಯಾಕೆ ಹೆಂಗ್ ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಈಗ S ನಲ್ಲಿ ಎಷ್ಟಿದೆ ಅಪ್ಪ? 0. S is 0, nothing. P ದಲ್ಲಿ 3 ಇದೆ, D ದಲ್ಲಿ 2 ಇದೆ. Done. So the his 6 hybrid orbitals that is overlap with the orbital F5, that is F is going to be the ligand here itself, right? So ligand here itself. Done. Ma'am, amines and biomolecules and electrochemistry. Yes, amines also I'm going to do it. Be in the class. We don't have this. After VBT we are having it. Okay, after VBT. This is VBT question only, appa. This is the VBT. VBT is also not there. Okay, no problem. Who has the VBT, they can learn it. Okay. So 3D, that is going to be the sp3d2 hybrid orbitals. Who has the whole coordination compounds? It's useful to them. Okay. Thus the complex has the octahedral geometry and it has unpaired electrons, and hence it is actually going to be the paramagnetic, because unpaired electrons are present in the d orbital. For that purpose we are going to consider it as what? Has a paramagnetic electron. Paramagnetic. Clear? Done? Yes. Next. Yes. So write the silent features of crystal field theory. So we need to write a silent features of crystal field theory. Concentrate properly everyone. According to the crystal field theory, the metal ligand bond is purely electrostatic. That is going to be what? Ionic. It's actually purely electrostatic it is. And it's a ionic. Clear? Ligands are treated as the point charges in case of the amines, anions and the dipoles in case of the neutral molecules. Okay, concentrate. ಯಾವಾಗ ligands ಇದೆ ಅಲ್ಲ, ligands ಎಲ್ಲ ಎದಕ್ಕೆ treat ಮಾಡ್ತಾರೆ? All the ligands will be treated as the point charges. ಅದೆಲ್ಲ point charges ಜೊತೆ react ಮಾಡ್ತಾರೆ. And in case of anions that will be done. In case of dipoles, neutral molecules will be done. Clear? Be active in the chat box everyone. Fast agi like button nama press ಮಾಡಿ because even you need to mark your attendance, right? Then the interfaction between a transition metal and the ligands arises from the attraction between the positive charged and metal cation. Between what? Positive charged and metal cation and a negative charge of the ligand. Concentrate properly. Positive charge du metal cation irutte, positive charge du metal cation irutte, matte negative charge du ligand irutte, okay. Due to this interaction, the density of the d orbitals is lifted and the causes the splitting of d orbitals. So adar salvagi d orbital split akkonta hogutte hybridization dalli. Clear up? Next, the splitting of the 5 dendrites of the d orbitals of the metal ion into the 2 sets of d orbitals with different energies under the influence of approaching the ligands and the ligand field. That is actually called as crystal field splitting. Okay, ಈಗ d orbital ನಲ್ಲಿ ಎದಕ್ಕಪ್ಪ split ಆಗುತ್ತೆ? Depends upon its energies it's going to get splitted, right? So ಆ field ನಲ್ಲಿ where it is getting been separated or spreaded out, that is going to be the crystal field theory. Clear? Now, the difference energy between the 2 sets of orbital is going to be the crystal field splitting energy. Okay, ಈಗ ಏನಪ್ಪ ಆಗುತ್ತಂದ್ರೆ the difference of that energy in splitting ಆಗ್ತಿದೆಯಲ್ಲ, that difference of that energy between the 2 steps of orbitals. ಅಕಸ್ಮಾತ್ ಈಗ d orbital ಮತ್ತೆ s orbital, ಇಲ್ಲ d orbital ಮತ್ತೆ p orbital. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತಪ್ಪ, ಆ difference of energy ಗೆ crystal splitting energy ಅಂತ ಕರೀತಾರೆ. Okay, that energy, that difference of that energy is actually called as crystal field energy. Okay, splitting energy, it is denoted as what? Symbols are this. Okay, so ಬಹಳ ಸಲ equations ಬರೀತ್ ಮುಂದು ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ symbols. So ಅವಾಗ ಏನಾಗುತ್ತೆ, there is a difference in the energy, to form a crystal field theory. Okay, next, what are spectrochemical series? Explain the difference between the weak field ligand and a strong field ligand. Okay, what is a spectrochemical series? The arrangement of the ligand in increasing order of their crystal field splitting is called as spectrochemical series. Is called as what? Spectrochemical series. So yavaga ligands anna increasing order nalli arrange ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೇವಲ್ಲ, ಅವಕ್ಕೆಲ್ಲ spectrochemical series ಅಂತ ಕರೀತಾರೆ. So this is how the spectrochemical series will be looked. Okay, now what is a weak and a strong one? Okay, the ligands which causes greater crystal field splitting. Okay, crystal field splitting ligands ಜಾಸ್ತಿ ಕೊಟ್ರೆ ಅದಕ್ಕೆ strong field ligand ಅಂತ ಕರೀತಾರೆ. Okay, if in case the ligands which will cause the greater crystal field splitting, ಅಂದ್ರೆ splitting of the d orbital, s orbital, p orbital ಜಾಸ್ತಿ ಇದ್ರೆ ಅವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? strong field ligands. Clear? If in case while those which causes the small crystal field splitting, then it is called as what? Weak filled ligands. It's going to be what? Weak filled ligands. Clear? Next, explain the crystal field splitting in a octahedral complexes. So octahedral complexes nalli splitting hengirutte? Splitting, how it will be there in the octahedral? Okay, carboxylic acids ಮತ್ತೆ amines ಇದೆಯಲ್ಲ. Okay, now explain the crystal field splitting in the octahedral complex nalli. In the octahedral complex, 6 ligands will surround the central metal ion. Okay, our ligands central metal atom ge full ಜಾಯಿನ್ ಆಗುತ್ತೆ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ CONH6 ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. CO is at the central atom. NH3 is being surrounded to that. How much? It's been surrounded how much? ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ ನೋಡಿ. ಇಲ್ಲಿ ತಗೊಳ್ಳಿ NH2 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 ಓಕೆ. ಸೊ ಈ ತರ ಇದು ಲಿಗ್ಯಾಂಡ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಈಗ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಲಿಗ್ಯಾಂಡ್. This ligand which is there, these are all the surrounded to it. These things are surrounded to it. Clear? So now dx2 minus y2 and dz2 orbitals. Like example, I'll show you. This is the structure actually how it's going to be. ಇಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಅನ್ನೋದು ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. This is very important. If you people have after VBT, then CF crystal field theory is very much important. There is CFT. Okay, which is CFT, concentrate, that is energy, concentrate here, energy versus this. So here what happens, XYZ, ಇಲ್ಲಿ metal d orbitals ಇದೆ, ಇದು ಪೂರ್ತಿ ಹೋಗಿ split ಆಗುತ್ತೆ. In what it is splitting? Concentrate, that is in dxy dyz and dxz. Clear? So this is dx square minus y square and dz square. Done. Now this is called as T2g. This is the energy of Eg. Done. Now whenever we are going to take a free metal ion or a ligand which is going to spread into the T2g and Eg. Clear? This is the splitting of d orbital in the octahedral crystal field. Okay, idu octahedral nalli most probably they will be asking you about the tetrahedral also. Okay, tetrahedral nu jaasti keltare because tetrahedral also I have asked a lot of times more than octahedral. Clear? So concentrate properly everyone. ಹೇಗೆ octahedral ಮತ್ತೆ tetrahedral ಆಗುತ್ತೆ ಅನ್ನೋದು ಎರಡು ಕ್ವೆಶ್ಚನ್ ತಗೊಂಡಿದ್ದೇನೆ. ಓಕೆ, metal d orbital is there, that metal d orbital, or else you can just take it out whichever the question they have given it. Okay, this is are directed along the direction of the ligands and experienced more repulsion, they have more energy. That is dxy, dyz and dzx. Okay, that is dxy, dzy, dxy, dyz and dsz orbitals. So that is going to be at the what? At T2g set. Okay, at T2g set and are directed between the axis of attacking the ligands. Axis of attacking the ligand and experiences the lesser repulsion by the ligands. So lesser repulsion irutte T2g kade. Okay, most of the probably T2g kade lesser irutte. Clear? And then they have a lesser energy. The energy separation between the two split sets is denoted as what? Delta naught. It's denoted as what? Delta naught. The energy of Eg orbitals increases by 3/5 delta naught and T2g set, and it will decrease from what? 2/5 of delta naught. 2/5 of delta naught. Clear? Clear? Yes, this is the structure how it's going to be there. Done. Now next question. Applications aitu. Okay. Okay, these are the few questions of, because ನಿಮಗೆ BBT ಆದ್ಮೇಲೆ ಇದೆಲ್ಲ ಅದಕ್ಕೆ ಅಷ್ಟೇ questions. Next you have aldehydes, ketones and carboxylic acids also, but in the portion for your FA it is actually only carboxylic acids. So I have taken only the questions of carboxylic acids. I have not included aldehydes and ketones in it. Okay, we in carboxylic acid nalli most probably the asked questions are preparations. Okay, preparations of carboxylic acid. This questions has been repeated a lot. So let's check it out. Okay, first question, explain the mechanism of the addition of HCN to aldehydes or ketones or carbonyl group. Okay, this is also aldehydes and ketones itself. Sorry. Next. Yes, this also reaction can be asked. Explain the Kirchner reduction. Yes, reduction with an example. So carbonyl group can also be reduced to the methylene group. It can be reduced to the methylene group also, that is CH2, by treating with hydrogen followed by a heating with the sodium or potassium hydroxide in the high boiling solvent such as ethylene glycol. Ethylene Glycol. Clear? So CH3CHO, which is a ethanol, which is going to react with hydrazine, that is NH2NH2, which will form a hydrozone, that is CH3CH double bond NNH2, and it will react with glycol in presence of KOH. ಈಗ ನಾವು catalyst ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಲ್ಲ, ಸೇಮ್ ಇದು catalyst ತರನೇ ಆಕ್ಟ್ ಮಾಡ್ತಿದೆ. It is giving us the product of ethane nitrogen, right? Ethane nitrogen form ಮಾಡ್ತಿದೆ with the help of what? Glycosol in the presence of KOH. ಅದು reaction ಅಲ್ಲಿ participate ಮಾಡಲ್ಲ, but it will help to make the reaction faster. Clear? Next suppose in case of a ketone ಹೇಗಾಗ್ತಿದೆ, it's not necessary in case of a ketone. Clear? Next, explain the preparation of carboxylic acid from nitriles. So this is very important. Carboxylic acid ಅಷ್ಟೇ ಇದ್ರೆ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಶಾರ್ಟ್ ಆಗಿ ಪ್ರಿಪರೇಷನ್ ಅಂತೂ ಬಂದೇ ಬರುತ್ತೆ, ಆಯ್ತಾ? ಶಾರ್ಟ್ ಆಗಿ ಪ್ರಿಪರೇಷನ್ ಬಂದೇ ಬರುತ್ತೆ. ಸೊ ಮೇಕ್ ಶ್ಯೂರ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಪ್ರಾಕ್ಟಿಸ್ ಇಟ್ ವೆರಿ ವೆಲ್. ಓಕೆ, next, hydrolysis of nitriles is a presence of acid or alkali has catalyst first gives the amides, which on further it will give what? Carboxylic acid. ಈಗ nitrile ತಗೊಂಡಿದ್ದೇವೆ, nitrile has been taken. ಆ ಜಾಗದಲ್ಲಿ ಏನು ತಗೋಬಹುದು, no problem. Let me take it as CH3C triple bond N in the presence of H2O, and then we are going to get CH3O double bond, sorry. Yes, CH3 double bond OH. Carboxylic acid will be formed. Clear? This is also preparation is very important. Carboxylic acid with the nitriles. They have asked this question for almost 2 marks. So practice it very well. 2 marks question idu. Ma'am, bare 2 marks. 2 marks score ಮಾಡಬೇಕು. Easy ಇದೆಲ್ಲ. Next, how would you prepare the carboxylic acid from Grignard reagent? This is also very important. ಇವೆಲ್ಲ ಶಾರ್ಟ್ ಆಗಿ. ಓಕೆ, ಸೊ ಈ ಕಾರ್ಬೊನಿಲ್, ಸೊ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ದ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಗ್ರಿಗ್ನಾಡ್ ರಿಯೇಜೆಂಟ್ ಇಂದ ಹೇಗಪ್ಪ ಪ್ರಿಪರೇಷನ್ ಆಗುತ್ತೆ? ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ಡನ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ ಗ್ರಿಗ್ನಾಡ್ಸ್ ರಿಯೇಜೆಂಟ್. ನಾವು ಗ್ರಿಗ್ನಾಡ್ಸ್ ರಿಯೇಜೆಂಟ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್. ಸೊ ಗ್ರಿಗ್ನಾಡ್ಸ್ ರಿಯೇಜೆಂಟ್ ತಗೊಂಡ್ವಿ, ಅದನ್ನ ಕಾರ್ಬೋನಿಲ್, ಓಕೆ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, that is also called as a dry ice, in the presence of dry ether to form a salts of carboxylic acid ಅನ್ನ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಕಾನ್ಸಂಟ್ರೇಟ್ ಪ್ರಾಪರ್ಲಿ. ಹಿಯರ್ ಆರ್ MgXCO2, which is actually in the form of a Grignard's reagent itself, which is forming what? RC double bond O MgX in the presence of hydrogen, means we are removing the hydrogen. We are going to get it as RCOOH. We are going to get what? RCOOH. Now concentrate for everyone. Here CH3CH2Cl, this is also called as chloroethane on alkali halide. It is an alkali halide. Clear? So this is also called as chloroethane and alkali halide, which in the presence of Mg and E2O, or E2O, we are going to get CH3CH2 MgCl. CH2 CH3 CH3 CH2 MgCl. Same other tara. Okay. Grignard's reagent we will call it. Now, in the presence of CO2 and H3O, we are going to get a propanoic acid, that is CH3CH2COOH. This reaction is also very important. Clear? This reaction is also very important, guys. So now, penyl magnesium bromide which is present, this in the presence of CO2 and H3O, we are going to get a benzoic acid, that is benzene, the C6H5OH plus COOH. Clear? Next question. What is the effect of CH3NO2 group on acidity of carboxylic acid? Okay, this is also 2 marks question. 2 marks question idunu. Okay, so what is the effect of CH3 ಮತ್ತೆ NO2 group? CH3 ಮತ್ತೆ NO2 group ದು ಏನಪ್ಪ ಎಫೆಕ್ಟ್ ಆಗ್ತಿದೆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಅಂತ. ಈಗ ನೀವು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಪ್ರಿಪರೇಷನ್ ಮಾಡ್ತಿದ್ದೇವಲ್ಲ, ಇವನ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೇವೆ ನಾವು, ಏನಪ್ಪ ಯೂಸ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ನೋಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಡ್ರಾಯಿಂಗ್ ಗ್ರೂಪ್, ದಟ್ ಇಸ್ NO2 will increase the acidity of the carboxylic acid. Okay, so ಇದು ಏನ್ ಮಾಡುತ್ತೆ NO2? This NO2 is actually increasing. NO2 is actually increasing the acidity. It's increasing the acidity of carboxylic acid. Carboxylic acid du acidity increase ಮಾಡುತ್ತೆ. ಅವಾಗ by stabilizing the carboxylate ion through the delocalization of negative charge. Through the delocalization of negative charge, it's been inductive and resonance effect also is happening. Because of the inductive and resonance effect is happening, because of that the electron is being donated. For that the decrease in the CH3 it will be. Okay, there will be a decrease in the CH3. CH3 will be decreasing the acidity. Okay, CH3 will be decreasing the acidity because electrons are donated. Clear? Electrons are getting denoted. See now, electrons ಈಗ ಕೊಡ್ಕೊಂತ ಹೋದ್ರೆ CH3 ಕಡಿಮೆ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ, ಆಮೇಲೆ NH3 ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. This much you remember. Enough. Okay. Next, explain the esterification. Explain the esterification reaction with an example. So this is also important. Carboxylic acid when heated up with the alcohols. When you are taking a carboxylic acid, you are reacting with the ethanol, that is with the alcohol itself, in the presence of mineral acid like concentrated H2SO4, and gives the esters. It will give what? Esters will be given to it, and this reaction is actually a reversible reaction and is also known as esterification. So ethanoic acid which is present, it will react with the alcohol, that is ethanol, in the presence of acid catalyst. Acid catalyst jode ethanoic acid ethanol jode react agutte. Clear? So what will be the ethyl ethanol will be formed? Ethyl ethanol plus the water will be the side product. This is also very important. Very important. If you have a carboxylic acid chapter, then this is very important. Okay. Next, explain the HVZ reaction with an example. So carboxylic acid which are having a alpha hydrogen atom and it is being treated up with the halogen. Alpha jode halogen jode react ಮಾಡ್ತವೆ. Okay. Alpha hydrogen atom ತಗೊಂಡು we are getting it reacted with the halogens. We are getting reacted with the halogens. Then the means halogen ಯಾವುದು ತಗೋಬಹುದು. If you want to take chlorine, bromine, whatever you want, you can take it. Cl, Br, anything you can take. Okay. In the presence of the red phosphorus, in the presence of what? Red phosphorus, we get alpha halocarboxylic acid. We are going to get what? Alpha halocarboxylic acid. Okay. This reaction is going to be what? Hell-Wohlhardt zinkic reaction, that is also called as HVZ. Okay, don't get confused. HVZ andre ee reactions anna baribeku. Hegappa reaction baribeku? Carboxylic acid ತಗೊಂಡ್ವಿ, ಆ ಜಾಗದಲ್ಲಿ ನೀವೇನು ತಗೊಳ್ಳಿ, CH2, CH3, C2H5 ಏನು ತಗೊಳ್ಳಿ, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Okay, in the presence of Br2, that is halogen, they have taken the halogen has a Br2. If you want, you can take it as Cl2 also, no problem. Clear? ಯಾವುದು halogen ತಗೋಬಹುದು, Br2 ನು ತಗೋಬಹುದು, Cl2 ನು ತಗೋಬಹುದು. In the presence of H2, we are going to get alpha bromo carboxylic acid. We are going to get what? Alpha bromo carboxylic acid. Clear? Next, what is the action of ammonium or on carboxylic acid? So what is the action of ammonia? Action of ammonia carboxylic acid जुड़ में. Okay, so carboxylic acids react with ammonia to give ammonium salts, which on further heating at high temperature it will give the amides. Clear? Concentrate. ಈಗ ಏನು ತಗೊಂಡಿದ್ದೀವಿ ನಾವು? CH3COOH ತಗೊಂಡಿದ್ದೀವಿ. Okay, that is getting reacted with the ammonium. Carboxylic acid is getting reacted with the ammonium to form ammonium acetate. To form what? Ammonium acetate in the presence, by heating it, by decreasing, means we are by removing the water, we are going to get a acetamide. We are going to get what? Acetamide. This is also important. This is also very important. Clear? So we are going to get what? Acetamide. Same with that also, amino benzonate also, and benzonamide is also been formed. Okay. This reaction separately also they will be asking it. This is also important. Clear? Next we are going to start up with the amines. We will start with amines. Okay. We have amines, few questions which has got repeated. Okay. Okay, we'll try to solve it. So we'll try to discuss it. Give an IUPAC name of, this all are 1 marks questions. Give an IUPAC name of CH3NH CH2NH2, that will be N-methyl lethine and amine. Okay. Next, write the IUPAC name of CH3 2N CH2 CH3. Athardunu IUPAC name nu barkobodu. Means what? IUPAC name short they will be asking the question. Okay. 1 marks nalli IUPAC will be asking a lot. Well, 1 marks questions. Okay, which is the more basic among the methylamine and aniline they have asked. Okay, yavadappa basic ide methylamine matte aniline dalli. So methylamine is actually a more basic compared to the aniline. To form the aniline only too many things will be done. So for methylamine it will be a very basic, easy it can be formed. Preparation is easy. Name the main product when aniline is being heated with the alcoholic KOH and chloroform. So yavaga aniline KOH, alcoholic KOH, and it will react with chloroform, what we are going to get? We are going to get penyl isocyanide and penyl carbolinamine and penyl carbolinamine. Clear? Next. Yes, these are all 2 marks questions. So when X in the presence of NaNO3 plus HCl by 0 degrees Celsius, what we are going to get a product has X and a Y, and what are the X and Y they have asked it. Clear? So X is going to be the aniline. Clear? Aniline in the presence of NaNO2 and HCl at 0 degrees Celsius, we are going to get a benzene diazonium chloride. Clear? Benzene diazonium chloride. So means what? Reactions hege keltare andre, sometimes they will give the Y, or else sometimes they will not give the X and Y, but the side product will be given to you. By only side product and the catalyst, you need to find it out what are the values of X and Y. Clear? ಏನಪ್ಪ X ಮತ್ತು Y ಜಾಗದಲ್ಲಿ ಬರುತ್ತೆ ಅನ್ನೋದು 2 marks ಇದು. Okay. What is Hinsberg's reagent? What is Hinsberg reagent? How do you distribute between that is primary, secondary and tertiary amines by using the Hinsberg's reagent? So primary, secondary ಮತ್ತು tertiary ಗೆ ಹೇಗಪ್ಪ ಮಾಡ್ತೇವೆ ಅನ್ನೋದು ನೋಡ್ಕೊಳ್ಳೋಣ. Okay. Experiment ಏನು ಹೇಳುತ್ತೆ actually amine plus Hinsberg's reagent and primary amine N-alkyl benzene matte sulfoamide is being formed, and it is also soluble in the sodium hydroxide solution. It is also soluble in the sodium hydroxide solution. Now secondary amine is what? N-N-Di, that is alkyl benzene, that is also sulfoamide is being formed, and it is being insoluble in the sodium hydroxide solution. Same with the tertiary amine, that is no reaction will be formed in the tertiary. Why? Because in the Hinsberg's reagent there will be no tertiary. Clear? Next, explain the preparation of the primary amines from the nitro compounds. So primary amines in a form madbeku with the help of the nitrobenzene. Clear? This also has been asked for the 2 marks a lot of times. Okay, 2 marks ge jasti baal sala kelidare adana. Practice it properly, everyone. Okay, 2 marks they have asked it a lot of times. Practice it. Oh. Done. Next, so nitrobenzene togondvi. With the nitrobenzene which is in the meta position, we are going to get in the presence of H2 or P2, in the presence of ethanol, aniline. Clear? This is how aniline will be formed. Next, nitro compounds are reduced to amines by using metals like Sn or Fe in acidic medium, So nitrobenzene you have taken it. Now in the presence of Sn and HCl and Fe plus HCl, we are going to get a aniline has the side product. Clear? So how the aniline will be formed? With the help of nitrobenzene in the presence of H2PD and in the presence of SnHCl. Next question, write the general formula of diazonium salt, that is ArN2 plus X. You can write it as this also. Okay. Next, with the example, explain the Hofmann's bromide reaction, that is also called as Hofmann's degradation reaction. This Hofmann's degradation reaction has been asked a lot of times. This is the name reaction also. named reaction ಮತ್ತೆ ಬಹಳ important reaction short ಆಗಿ ಬೀಳುತ್ತೆ at least for 3 marks they will be asking it. Okay, amides on heating with the bromine and aqueous NaOH. So yawaga amides, so this amide which is actually getting reacted with the 4NaOH in the aqueous medium, by heating it you are going to get a primary amine plus Na2CO3 plus 2H2O plus 2H2O. Clear? Example ಏನು ತಗೋಬಹುದು? Acetamide, that is CH3CONH2Br plus NaOH. This will in the presence, by heating it we are going to get a methylamine plus H2O. Methylamine plus H2O. This is the side product which you are going to get it for the example number 1. Example number 2 ನಲ್ಲಿ benzamide ಜೊತೆ react ಮಾಡಿ aniline ಹೇಗೆ form ಆಗುತ್ತೆ? ಯಾವಾಗ C6H5 is getting reacted with CO and NH2 and bromide. Clear? C6H5 CO ಮತ್ತೆ NH2 ಮತ್ತೆ NH2 ಜೊತೆ ಈ benzamide bromide ಜೊತೆ react ಮಾಡಿ with 4NaOH of aqueous solution, we are going to get a aniline, that is C6H5NH2. C6H5NH2. The structure will be in this way. Okay. Okay, it's okay. ಅಂದ್ರೆ ಎಲ್ಲ ತರದ ಸ್ಟ್ರಕ್ಚರ್ ತಗೋಬೇಕಾಗುತ್ತೆ, it will take time. Okay, next, explain the preparation of primary amine by a Gabelstal's amide synthesis. So when the benzamide reaction with KOH to form a potassium amide, that is the potassium amide on treatment with the alkyl halides, it will give N alkyl amide, which on hydrolysis with the strong alkali like NaOH, pure primary amine is being formed. Okay, pure primary amine is being formed. Clear? Pure primary amine is being formed and it is called as Gabelstal's synthesis. It's also called as Gabelstal's synthesis. Clear? So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಇದು ರಿಯಾಕ್ಟ್ ಆಗಿ N alkali bathylamide at the presence of primary amine, with the presence of primary amine. Clear? Next, what is carboxylene reaction? Whenever the primary amine is being heated up with the chloroform and alcoholic KOH, it's going to give us a carboxylic amines, and that reaction is going to be what? That reaction is going to be what? Carboxylic amine reaction. That reaction is going to be what? Carboxylic reaction. Clear? One second, guys. Okay, done. Now few more questions are there. Okay, so name the product X and Y. I told you amines nalli keltare ee tara X ಮತ್ತೆ Y find ಮಾಡಬೇಕು. They will give the CONH2 in the presence of Br2NaOH. We need to find the X value and Y value here. Okay, so how you are going to do it now? X is going to be the aniline here. So whenever the aniline is getting reacted with CONH2, we are going to get the product in the presence of CH3COCl. We are going to get a product as acetylide. Okay, acetylide. Clear? So or it is also called as N-pentyl acetylamide. Clear? Next, B in kelidare. Yes, name the final product of the amylosis of an alkyl halide kelidare. So that is going to be the methylamine. It is also a strong base than the ammonium. This is also called as a very strong base of an ammonium. Done? Clear? Understanding? Next, how are the primary amines prepared from nitro compounds, and write the equation. So hegappa primary amines prepare agutte with the help of the nitro compounds. And next question is, how does the Heisenberg's reagent react with the ethyl amine? They have asked it. Okay, now if in case you are going to react the primary amine preparation with the help of the nitro compounds, then RNO2 in the presence of H2 or Ni, we are going to get the product as RNH2, and C2H5NH2 in the presence of C6H5SO2 with Cl, we are going to get a product as C2H5NH and SO2C6H5 plus HCl. Clear? In the presence of H2 or Ni. Done? Done? Clear? Yes. So next question they had asked about the Heisenberg's reagent react with the ethylene amide, that is N and dimethyl benzene amide. Clear? So yes, today this is the whole chapter which I was able to explain today. In case ಯಾರಾದ್ರೂ ಬೇರೆ ಬೇರೆ ಚಾಪ್ಟರ್ಸ್ ಇದ್ರೆ ಹೇಳ್ಬೋದು ನನಗೆ ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೇಳಿ ಫಾಸ್ಟ್ ಆಗಿ. ಆಮೇಲೆ ಯಾರಾದ್ರೂ ಕ್ಲಾಸ್ ನೋಡಿದ್ರೆ, ಇನ್ ಕೇಸ್ ಈಗ ಕ್ಲಾಸ್ ಯಾರು ನೋಡ್ತಾ ಇರಲ್ಲ, who are seeing it and now they can also tell me that what is the portion for you people. I have explain how much portion I have got it. According to that I have taken the questions and I have told. In case ಯಾವ್ದಾದ್ರು extra idre, we will do that also in the next session, don't worry. So first PUC gunu bartide. First PUC also you are going to get all the most important questions for you people. So fast agi hogi subscribe ಮಾಡಿ channel ge, all share all with your friends. So friends ge share ಮಾಡ್ತೀರಾ, they will also get to know that the FA-3 preparation has been started already and we are helping you people. Make sure you will share it with your friends also. And if in case ಏನಾದರೂ ಬೇರೆ ಬೇರೆ ಪೋರ್ಷನ್ಸ್ ಇದ್ರೆ ನೀವು ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೇಳಿ, ಅದ್ರ ಪ್ರಕಾರ we will check it out and ಅದ್ರ ಪ್ರಕಾರ ನಾವು ಕ್ವಶನ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಆಯ್ತಾ? So this PDF will be available when you people are going to hit 30 likes on the video. 30 likes ಯಾವಾಗ ಬರುತ್ತೆ ಅವಾಗಷ್ಟೇ ನಾನು PDF ಹಾಕೊಳ್ಳು. ಸೊ ಫಾಸ್ಟ್ ಆಗಿ ಲೈಕ್ ಬಟನ್ ಹಿಟ್ ಮಾಡಿ, so that we will get the 30 likes and then afterwards I will upload you people the PDF. Clear? ಸೊ ಅವಾಗಿನ ತನಕ ಕುಂತು ಚೆನ್ನಾಗಿ ಕ್ಲಾಸ್ ಕೇಳಿ, then only you people will be clear to it. Okay, so till then see you everyone. Simultaneously ಯಾರು KCT ಪ್ರಿಪರೇಷನ್ ಮಾಡ್ತಿದಾರಲ್ಲ ಅದಕ್ಕೂ ವಿಡಿಯೋಸ್ ಹೋಗ್ತಿದೆ, you can check it out. KCT ಪ್ರಿಪರೇಷನ್ ಎಲ್ಲ ಕ್ಲಾಸಸ್ ಹೋಗ್ತಿದೆ, ಚಾಪ್ಟರ್ ವೈಸ್ questions will be solving in the KCT classes. Go and you can go and check those classes also. Till